Hello. Hello, my dear friends. Anyone is in live? Just say me hi. If anyone is in live, just say me hi. I hope the video and audio is clear. If anyone is in live, just say me hi. So that I get to know that the video and audio is clear. I hope the video and audio is clear, right? Good evening, good evening. Now, I hope the video and audio is clear. Once you see me, whether the video and audio is clear or not. If the video and audio is clear, yes. Okay, fine. Now we'll wait for the just 2 minutes. Let others to join so that we can start the lecture. Now this is a chemical equilibrium, which is very important topic for our JEE as well as a NEET. Now, the one who is in the live, just say me hi. If anyone is in the live, just say me hi. Anyone is in live? Good evening, good evening. Right. Now we'll start the lecture chemical equilibrium. Right. Now let to start the class. Now, before going to start the lecture, here what is the meaning of the chemical equilibrium? Can anyone? What is the meaning of the equilibrium and what we are going to study in the equilibrium? Now the equilibrium is a very important chapter. That equilibrium chapter has been divided into two types. One is a chemical equilibrium and one is a max I will complete today. Chemical equilibrium chapter max I will complete today. Maybe up to within 2.5 hours or 3 hours it will be completed, including questions. If you do the questions very fastly, now it may be completed by less than 4 hours. Okay. Now, the equilibrium chapter has been divided into two types. One is a chemical equilibrium and one is a ionic equilibrium. But in our NCERT equilibrium chapter, they have given it as only one, and we have dividing it into the two. First, we are going to study about the chemical equilibrium. Then we are going to study about the ionic equilibrium. First, we'll deal with the chemical equilibrium. Clear? Now, what is the meaning of the chemical equilibrium? The state of the system at which pressure comma temperature comma volume and the composition having fixed fixed volume and does not vary with the time is called equilibrium, right? Now here, sir, the state at which temperature, pressure and the volume and the composition of the fixed volume and does not vary with the time is called as a equilibrium. Clear? Now can we give me the general example for this one, sir? Okay, now I will give. Let's suppose we'll take the one vessel. Clear? For this vessel, now it is a tap. The water it is coming from the tap. Okay, now let's suppose this water it is coming from the 5 kilometer per hour. Let's suppose the water it is coming. Now what happened to the vessel? Water level in the vessel will be increased, right? And the next condition, what I will do, for this same tap water which it is coming for the 5 kilometer per hour, now I will make one small hole, that from here, from this vessel, water it is going from the 2 kilometer per hour. Then what happened to the water level in the vessel? What it will happen? It will be increase or it will be decrease? Can anyone? Now here the water it is coming from the 5 kilometer per hour and the water it is going for the 2 kilometer per hour. What happened to the water vessel? Clear? Now it will be slowly, but vessel, what it will happen? Water level in the vessel will be increase or decrease? No. In the first case, water it is coming from the 5 kilometer per hour, so volume level will be increased. Now in the vessel it will be increased. That's what I am asking. In the vessel water level will be increase only, but not that compared to the one. Now the third case, what I will do? Now in the third case, now the water level here same, water it is coming from the 5 kilometer per hour. Okay, now here also water it is going from the 5 kilometer per hour. Now what happened to the water vessel? Or level of the water vessel? What happened? It will be remain same or it will be increase or it will be decrease? In the third case, this is the third case and this is the second case. In the third case, now water it is coming from the now here from the tap water it is coming from the 5 kilometer per hour. Now the water it is going from the 5 kilometer per hour. Then level of the water vessel which is present in the vessel, now its volume will become same, remain same, right? Why? Water it is coming from 5 kilometer per hour and water it is going from the 5 kilometer per hour. Now that time and this state we call it as a equilibrium. Now can anyone say me, now the whatever may be the equilibrium it has been established here, it is a dynamic equilibrium or static equilibrium? This is a dynamic equilibrium or the static equilibrium? Now here the 5 kilometer per hour the water it is coming, the same 5 kilometer per hour the water it is going, then the level of the water will be remain same, then this time we call it as a equilibrium. Now this is water it is coming and water it is going, right? Water it is coming and it is a water it is going. Now here the vessel it is remain same, so this is a dynamic equilibrium, right? Equilibrium is a dynamic. See, rate of forward reaction and the rate of backward reaction means water it is coming and water it is going, but we are not seeing any change in the volume. Means here the forward reaction is happening, backward reaction is also happening, but there is no any change in the volume, and that time we call it as a equilibrium. Is it clear? Now this is the totally it has become stopped. Static means there is no any forward reaction and there is no any backward reaction. Here rate of forward reaction and the backward reaction is happening. Done? Now, here the next, the chemical, how many types of chemical equilibrium has been divided? How many types the equilibrium has been divided? Now, how many types the equilibrium has been divided? How many types the equilibrium has been divided? Now, the equilibrium has been divided into two types. Yes, it has been divided into two types. Chemical equilibrium has been divided into two types. One is reversible, and one is a irreversible. One is reversible and one is a irreversible. Clear? Now, what is the meaning of reversible equilibrium and what is the meaning of irreversible equilibrium? Means irreversible equilibrium means it proceeds in only one direction. It proceeds in one direction. It proceeds in one direction is called as a irreversible. Clear? Now, example which completely converted into the products. Now, irreversible examples are, if you take the 2 moles of KClO3, now it will be converted into the 2 KCl plus 3 O2. Now, this is some decomposition reaction. And next, neutralization reaction, HCl plus NaOH gives rise to NaCl plus H2O. This is also one example for the which one? Irreversible reaction. And another example we are having combustion reaction. Combustion reaction example, CH4 gas, methane gas in the presence of O2 gives rise to CO2 plus 2 moles of H2O, and here it will be the 3 moles of oxygen. Clear? Done? Now here it is a 4, right? 2 moles of oxygen plus 2 O2, right? Now these are the namaste everyone, right? Now these are the examples for the irreversible reaction. Now what is the meaning of the reversible reaction? Means now reversible reactions. Now reversible reaction means in this reaction reactants not completely converted into products. Reactants are not completely converted into products. These are known as a reversible reaction. Example, now can anyone say me reversible reactions will be established in the closed container or open container? Reversible reactions will be established in the closed container or open container. Now, reversible reactions will be established in the closed container or reversible reactions or equilibrium will be established in the closed container only. Closed container only. Don't get confused. Clear? Now, what is the meaning of the reversible reaction? Means reversible reaction proceeds in the two direction under the same set of experimental condition. Reactants converted into the product. Now, reversible reactions. Here, what is the meaning of the reversible reaction? Let's suppose this is a one reactant. Now, this reactant converting into the product. Clear? Now, this one we call it as a forward reaction. Now, in the same way, product converting into reactant. Now, this one we call it as a backward reaction. Example for the reversible reaction. Now, H2 gas plus I2 gas equilibrium to give the 2HI gas, right? Now, next one. Next example, we are having CaCO3 solid plus carbon solid equilibrium to give the calcium oxide solid plus 2 moles of CO gas, right? Now this is a reversible reactions example. May I know what is the difference between the first example and what is the difference between the second example? What the first example we will call and what the second example we will call? Now the first example is the example of heterogeneous equilibrium or homogeneous equilibrium. First example is the example for heterogeneous equilibrium or homogeneous equilibrium. First one is the example for the homogeneous equilibrium. Why? Because in all the reactants and the products are in the same phase. If the reactants and the products are in the same phase, that we call it as a homo. This one we call it as a homogeneous equilibrium. Clear? And second one you can see, in this second one we are having reactant is present in the solid. Now here product we are having the solid as well as the gas. So if reactants and the products, if we are having the two different phases we are saying, right, two different phases, then we can say this as the heterogeneous equilibrium. Clear? Done? Now next we are going to see the physical equilibrium and as well as a chemical equilibrium. Now what is the meaning of the physical equilibrium? Physical equilibrium means only the phase it is changing, we call it as a physical equilibrium. Now physical equilibrium means equilibrium involves only in a physical state. Equilibrium involved only in the physical state is called as a physical equilibrium. Example, H2O solid equilibrium with H2O gas. Clear? Now this one we call it as a melting, vaporization, condensation or sublimation. First one, solid converting into liquid and solid converting into liquid, we call it as a melting. Okay, good. Second one, H2O liquid equilibrium to give H2O gas, we call it as a vapor, right? Now next one, now third one, H2O solid converting into H2O gas. Clear? Now H2O solid converting into the H2O gas, we call it as a which one? Sublimation. Clear? Now these are the some physical equilibriums that you have to remember. See, only the phase of the substance is changing. This reactants phase only it is changing. Solid converting into liquid, liquid converting into gas, solid converting into gas. Now next one, chemical equilibrium. Next one we are having chemical equilibrium. Now what is the meaning of the chemical equilibrium? Equilibrium involved in change in chemical state. Equilibrium involved in change in chemical state, we call it as a chemical equilibrium. Example, 2 moles of HI gas equilibrium with H2 gas plus I2 gas. Clear? H2 gas and the I2 gas. Another example, PCl5 gas equilibrium with PCl3 gas plus Cl2 gas. Right? Now here you can see, now PCl5 has been converted into PCl3 and the Cl2. Now this one we call it as a chemical equilibrium. Now, the next very important point that we are going to see in this equilibrium, many of the students, they may have the misconception here about the graphs. Whenever the graphs they have given, you have to be very careful with the whether the graph they are asking according to the rate versus time or concentration versus time. Okay, now we are going to see the graphs of equilibrium. Now, the one key point that you have to remember that equilibrium will be established only in the closed container, right? If you take the open container, let's suppose I will take one example for you. CaCO3 solid, if it is heated, what it will be converted? It will be converted into the CO2 gas plus CaO solid, right? Now, if suppose this reaction is happening in the open vessel, when this CaCO3 solid, if I was heating, what it will happen? In this mixture, there will be only the CaO solid, but CO2 gas will be evaporated, right? If the CO2 gas, if it is evaporated, again how this calcium oxide, again it will be converted into the calcium carbonate. It is not at all possible, right? If the reaction, if it is happening in the open vessel, let suppose if you take the closed container, if this reaction, if it is happening in the closed container, there is no chance to escape the CO2 gas. Then if there is no chance to escape the CO2 gas, again this calcium oxide and this CO2 gas again combines to give the calcium carbonate. So equilibrium will be established in the closed container. Now we'll see the graphs for the equilibrium. Now, what are the graphs for the equilibrium? The first key point you have to remember that here, let's suppose one reaction will take PCl5 gas equilibrium with PCl3 gas plus Cl2 gas, right? Now, initially at a time t is equal to 0, I was taken the 5 molars of PCl5. Now, initially I was taken only the reactant. Reaction has not started, means there is no chance of forming the product. Then when they have reached to the equilibrium, from the 5 moles, 2 moles of the PCl5 has been converted into PCl3 and Cl2. Sir, how this 2 and came? Means now you see, for this reaction, 1 mole of PCl5 is giving 1 mole of PCl3. From these 5 moles, I was what? From these 5 moles, the 2 moles have been dissociated. These 2 moles, when it has been dissociated, for these 2 moles, how many moles of the PCl3 should be formed? 2 moles, right? So that's the reason, same 2. Again for the 2 moles has been formed. Here, now, here, if I want to draw a graph between rate versus time, okay, you can see at a time t is equal to 0. Now, this is a reactant, right? Reactants are high. Now, as the time proceeds, reactants are decreasing. Now, reactants are decreasing. Now, products are increasing, right? Reactants decreasing, products are increasing. Means as the time passes, reactants decreasing. Now, products are increasing. One point when it has reached to the equilibrium, then forward reaction and the backward reaction has become stop. Means what does it mean? Equilibrium, what does it mean? Means here from the 2 moles at that time when they have reached to the equilibrium time, from the 5 moles of the PCl5, how many moles has been converting into PCl3 and Cl2? 2 moles, right? Means this 2 moles which has converting into the product, the same 2 moles again combining to give the 5 moles of the PCl. Here this 2 moles has been converting into PCl3 and the Cl2, and at the same time this 2 moles again, 2 moles of PCl3 and Cl2 again combining to give the 5 moles of the PCl5. That time we call it as a equilibrium time. Clear? Now the rate of forward reaction and the rate of backward reaction, when they have became equal, and that point we call it as a equilibrium point. That point we call it as a which point? Equilibrium point. This is the one key point you have to remember. This is a one key point you have to remember. At the equilibrium, rate of forward reaction and rate of backward reaction will be equal. Rate of forward reaction and the rate of backward reaction will be equal. Now the next key point that you have to remember is, it is, I hope it is clear, or still you are having any confusion? I hope it is clear. Now at the equilibrium, rate of forward reaction and the rate of backward reaction will be equal. Clear? Now first one, note the state at which rate of forward reaction, the state at which the rate of forward reaction equal to rate of backward reaction is called chemical equilibrium. At equilibrium, rate of forward reaction will be equal to rate of backward reaction. Rate of forward reaction will be equal to rate of backward reaction. This is the one very key point that we are going to use. Done? Next one, at equilibrium rates may be equal, but concentration may or may not. Very key point that it is, at equilibrium concentrations may, or concentration of reactants and the concentration of the products may or may not equal. Okay. Now here, how to justify this one? Same experiment I was taking with the 3 different terms. Let's suppose PCl5 gas converting into PCl3 gas plus Cl2 gas. Okay. Now this reaction as came to the, let's suppose 5 moles I was taken 0, 0. Now this reaction after completion of 25%, better I will take 1 mole so that it will be clear for you. Now from 25, after the 1 mole, 25% only after the completion, equilibrium has been came by the experiment, 0.25. Okay, 0.25 has been formed. Next condition I was taking, after the 50% is completion, equilibrium has been came. So 1 minus 0.5, 0.5 and 0.5. Clear? Now the next experiment, after the completion of 75% of the reactant, now 1 minus 0.75, 0.75, 0.75 has been formed. Now these are the 3 experimental data I was having. Now with these 3 experimental data, now how the equilibrium is attaining. Now we'll see with the first experimental data. If I want to draw a graph between concentration versus time, if I draw a graph between concentration versus time for the first experiment, this is the first experiment I was going to draw the graph. Now let's see, initially at a time t is equal to 0, concentration of the reactant is 1. This is 1, let's suppose. This is 0.75, let's take. Now this is 0.5. Now this is 0.25, let us do. Okay, and this is a 0. Now at a time t is equal to 0, concentration of the reactant is 1. Now concentration of the products is 0. Done. As the time pass, now concentration of the reactant has been decreased to the 0.75, because from the 1 0.25 has been gone. Then after that it has become constant, because rate of because 0.25 is converting into the products, same 0.25 combining to give you the 1 mole of PCl5. The same thing 0 up to 0.25, which one? Products has been formed, and after that it has become constant. Means where the concentrations of the reactants and the products has became neutral or constant, the time where the concentration of the reactants and the products has became constant, that time we call it as a equilibrium. See here the rate of forward reaction and the rate of backward reaction, no, there is no need to coincide the two graphs at a time. Clear? May or may not for the concentration. For the rates it may be coincide, but for the concentration graphs may or may not. Okay, you should not get confused with this one. Here first with the experimental data we got to know. Here after the at this time both the concentration of the reactants and the concentration of the products has become constant. Now this time we call it as a equilibrium time. Here and this point we call it as a equilibrium. Then now we'll go with the second experimental data. With the second experimental data, if you draw a graph, same thing. This is 1, this is 0.75, now this is 0.5, now this is 0.25, right? Now the concentration of the reactants has been decreased. Now the concentration of the products has been increased. Now both has become constant here. Now this point we call it as a equilibrium point. Now the next point, next one, this is when the equilibrium attained, at a 50% completion of the reactant. Now the next one, concentration versus time. This is concentration versus time. Now this is also concentration versus time. Done. Now the concentration of the products has been came to the 0.75. Now the concentration of the reactants has came to the 0.25. Now after that it has become constant. Here you may get a doubt. This point is the equilibrium point, or I will draw. Now this is a 1. Now this is a 2. Now 2 is the equilibrium point or 1 is the equilibrium point. Now see me. Now for this third graph, 1 is the equilibrium or 2 is the equilibrium. Clear? Now here the concentration versus time, for the concentration versus time, now the concentration of the product and the concentration of the reactant both has become constant, right? Now that time we call it as a equilibrium. So this is here rate of forward reaction, rate of backward reaction may be equal. This second one will be the which one? That one we call it as a equilibrium. I hope it is clear. For the equilibrium graphs are clear. Now for the rate of forward reaction and the rate of backward reaction may be equal at equilibrium, but the concentrations you can see may or may not be equal. Done. Right. Next one. Here based on this one, now we have to express the rate for the equilibrium reaction. To express the rate for the equilibrium reaction, now how to express the rate for the equilibrium reaction? Before going to express the rate for the equilibrium reaction, we are going to study about the characteristics of the equilibrium reaction. Now what are the characteristics of the equilibrium reaction? Characteristics of equilibrium, characteristics of chemical equilibrium. Done. Now what are the characteristics of the chemical equilibrium? First point of the characteristic of the chemical equilibrium established only if reaction carried out carried out in a closed vessel. Okay, in the closed vessel. In the closed vessel. Right. Now, how to express the equilibrium reaction? Let's suppose this reaction, if they have given in this manner, calcium carbonate upon if they have given, now that indicates that this reaction is happening in the open vessel. Okay, this reaction is happening in the open vessel. Let's suppose if this reaction, if they have given in this manner, calcium carbonate solid, now equilibrium with calcium oxide plus CO2 gas, if they have given in this manner, that indicate that this reaction is happening in the closed vessel. This reaction is happening in the closed vessel. Done? Clear? Now the first one. Next one. At equilibrium, properties like concentration, density, viscosity, surface tension, color, etc. does not change with the time. The next point you have to remember that at equilibrium, concentration, density, surface tension, color, etc. does not change with the time, until unless if we disturb the equilibrium. Right? Next one, the very key point, that is a chemical equilibrium. Chemical equilibrium is dynamic in nature. Already I was explained, right? Dynamic in nature means rate of forward reaction and rate of backward reaction both will be happening, but there is no any change in the volume. Good evening Kalidasan, good evening. Now chemical equilibrium is dynamic in nature. This is the one very key point you have to remember, because it is not the static. Static means there is no any change. Clear? The very key point that you have to remember, see, based on this concept only, in the 2025 they have asked the question. That what is the question they have asked, I will discuss, but listen the concept. First of all, now catalyst does not affect the equilibrium. The first key point you have to remember, that catalyst does not affect equilibrium. Catalyst does not affect the equilibrium. This is the one very key point you have to remember. So what the catalyst will do for the reaction? The catalyst will do our equilibrium to attain very fast or equilibrium to attain very slow. That only it will do, but it will never and ever disturb the equilibrium. Clear, sir? It may do the what? It may make the equilibrium to attain very fast, means to decrease its activation energy. That also, which catalyst will be make the reaction or make the equilibrium to attain very fast? Which catalyst will make the or to attain the equilibrium slow? Can anyone? Let's suppose I will draw the graph. Based on that one, you have to say me. Now this is rate versus time. Okay, I will draw the graph. 3 graphs I will draw. Now for which one the catalyst used as a positive, for the which one we have used the catalyst as a negative. Okay, now here the 3 graphs we are having, right? Here the 3 graphs we are having. Okay, now which one is a positive catalyst, which one is a negative catalyst, and which one? Right, red is a negative catalyst. Now normally white one is a, let's suppose this is a reaction, A gas equilibrium with the B gas plus C gas. Okay, now this is a reaction. When this reaction has happened, now the equilibrium rate of forward reaction and rate of backward reaction, I got this one. The graph for this reaction, I got this white one. Okay, now for this reaction, for this closed container, I have added the positive catalyst. Clear? I have added the positive catalyst. By that, what it has happened? Now this catalyst role, what the catalyst has did, now it has been make that to attain the equilibrium very fastly. This positive catalyst made equilibrium to attain very fastly. Then after that, for the same reaction, I have added negative catalyst. Now when I have added the negative catalyst, then what did happen? Negative catalyst made activation energy high. Due to that, what it happened? Now it made equilibrium to attain very slow. See, it took very high time to attain equilibrium. Now this is a normal equilibrium time. Now this is a positive catalyst. Now this is negative catalyst and this is normal catalyst, normal reaction. I hope it is clear. Role of the catalyst is clear. Role of the catalyst is clear or not? Clear, right? Now based on this one, 2025, we got one question. Now I will write that question. You have to say me the answer to it. Right? Wait 1 minute. All right. No. Statement 1. Statement 1 they have given a catalyst cannot alter the equilibrium constant of the reaction. Equilibrium constant of the reaction, temperature remaining constant. Okay. Now statement 2. They have given a homogeneous catalyst can change equilibrium composition of a system, temperature constant. A temperature remains constant. Now say me the answer for this one. Both the statements are true. Statement 1 is true and the statement 2 is false. Now both are false. Now say me the answer. What is the answer to it? What is the answer to it? What is the answer to it? This is JEE Mains 2025. First one is correct, second one is false. First one is correct. Kalidasan is saying the first one is correct and the second one is false. What is saying? Catalyst cannot alter the equilibrium constant of the reaction. A catalyst cannot alter means it will not involve, right? See, the catalyst will not involve in the equilibrium reaction. A catalyst cannot alter the equilibrium constant of the reaction. That it is true. Disturb or change. Change. Alter means change. It will not change, right? Cannot change. Change. It will not change. Catalyst cannot alter the equilibrium constant, means it will not change. So catalyst, it will not change. Catalyst, what it will do? Either it will make the equilibrium to attain very fast or very slow. So the statement 1 is true. Statement 1 is true. Now, homogeneous catalyst can change the equilibrium composition. No, catalyst will never and ever will change. How can it change? Equilibrium constant is saying. Equilibrium constant of reaction is saying. Let's suppose, okay, I got it, your doubt. Let's suppose A gives rise to B plus C. Okay. For this reaction, Kc I got it as 2. Okay. No. Listen. For this one, Kc I got it as 2. At 5 minutes. At 5 minutes I got. Right. I have added the positive catalyst. When I have added this positive catalyst, Kc will be same, or it is Kc will be 2, or Kc will be 1, or Kc will be 5. Here the Kc will be 2 or 1 or 5. When I have added positive catalyst, here Kc will be same, but the time will change. Time within 3 minutes it came. How less than 2? Catalyst will not involve in reaction. Catalyst will make equilibrium to attain very less time. Initially, when I have not added positive catalyst, Kc is equal to 2. When I have added positive catalyst, 5 minutes. Let's suppose when I have not added the positive catalyst, Kc will be same, but time will change. So that here is saying cannot alter equilibrium constant of the reaction. Read the statement carefully. Equilibrium constant of the reaction. So this is true. Now he is saying he can change the equilibrium composition. No, catalyst will not change the equilibrium composition. So this is false. Statement 1 is true. Statement 1 is true. Statement 2 is false. This is your JEE Mains 2025 question. This year itself they asked. Okay. I hope it is clear. Can we move to the next question? Survey. Can we move to the next concept? Right. Now, before moving to the next concept, for any equilibrium reaction, how to express the rate? For any equilibrium reaction, how to express the rate? Means what is the meaning of the rate? Means rate indicates that how much fast that equilibrium it is attaining, that it should follow the law of mass action. Now what is the law of mass action? How it will be followed? Now I will say. Let's suppose this is a one equilibrium reaction. A gives rise to B. First let me complete the concept. Based on that one, we'll do the more questions. I brought n number of questions. First let me finish the topic. By topic wise topic, we'll do the questions. Okay. Now this is A is moving to B. means this is a forward reaction. This one we can say it as a rate of forward reaction. B again coming to the A. This indicates that this is a rate of backward reaction. Clear? Now the rate of forward reaction is directly proportional to the concentration of the reactant only. So what does it mean? Just example how to say reaction, whether it is obtaining equilibrium, whether the reaction converting into the product, that it will be depend upon the concentration of the reactant what we have taken. Clear? Now the concentration of the reactant, if it is in the aqueous, we will express in the form of concentration. If it is in the form of the gaseous, it will be expressed in the form of the partial pressure. Now you may get a doubt, sir, the pure solids and the liquids also will be there. Now how to express them? That I will explain, but now you listen. For any equilibrium reaction, if I want to express the rate, that rate I will express on the basis of the which one? Reactants. So the rate of forward reaction is directly proportional to the concentration of the reactant. For this one backward reaction, if I want to express, now the rate of backward reaction is directly proportional to the concentration of its reactant, because B is the reactant, right? Done. Now when I was removing this proportionality constant, one new constant I got. Now rate of forward reaction is equal to, now rate constant of forward reaction into concentration of reactant. Now for rate of forward reaction is equal to rate constant of backward reaction into concentration of the reactant. Clear? Now we know at equilibrium rate of forward reaction equal to rate of backward reaction. Rate of forward reaction equal to rate of backward reaction. Then I can say Kf rate of forward reaction equal to rate of backward reaction means, now rate constant of concentration of A equal to rate constant of backward reaction into B. Clear? Now reaction reached to the equilibrium. Rate of forward reaction and rate constant of backward reaction, when they have became equal, that point or that time we call it as a which one? Equilibrium time. Now how these equilibrium reactions are following the law of mass action. This law of mass action, many of the students they will get misconception, or it will make some complicated to understand, but I will explain with the very simple example. Just you listen. What is the meaning of the law of mass action? Now the equilibrium reactions will follow the law of mass action to express its rate. Means how much fast the reaction is attaining to express that one mathematically. Now we have to follow the law of mass action. Okay. Now what is the meaning of the law of mass action? Law of mass action. Law of mass action. This one we call it as a LOMA. Done. Now here law of mass action will be expressed for the two reactions. First I will express it for the aqueous reaction. Okay, first I will write the what is the definition of the law of mass action. At a particular temperature, rate of chemical reaction is directly proportional to product. Don't think that it is a product means now our reactant and product means multiplication, directly proportional to product means that is a multiplication. Okay, that also I was writing. Product of activity masses of reactant and rise to the power of its stoichiometric coefficient. of its stoichiometry coefficient. Clear? Done? Now we'll see. Let's suppose I have taken one example, 2a aqueous plus 3b aqueous gives rise to 4c aqueous. Done? Now, if I want to express rate for this reaction, how to express? Now, this rate is equal to concentration of A raised to the power its stoichiometric coefficient 2, concentration of B raised to the power its stoichiometric coefficient 3. Because this reaction is following the law of mass action. Law of mass action can be expressed for the aqueous reaction. Aqueous reaction will follow the concentration. So my dear friends, you have to be very careful with this one. Now concentration is nothing but molarity. Concentration is nothing but molarity. Molarity is equal to N by V. So this molarity in our chemistry we can express with the C, either we can express with the M, either we can express with the square bracket. Don't get confused. Okay, these three terms indicates that this is a concentration term only. If I have expressing the concentration as a C, that is same. If I have expressing M, that is same. Now square bracket is also same. Aqueous species will be following concentration. That concentration I have expressing in the form of square bracket. Done? Next, let's suppose if this reaction, if it is happening in the gaseous form. Sir, how the activity coefficient is following concentration and the pressure, I will explain, don't worry. Okay, plus 3b gas gives rise to 4c gas, right? Now if I have to express this reaction, if I want to express the rate for this reaction, rate is equal to, now rate constant into partial pressure of reactant raised to the power its stoichiometric coefficient, partial pressure of B raised to the power its stoichiometric coefficient. So why we should express for the aqueous species concentration, for the gaseous species partial pressure? Now we'll see. Now activity coefficient. Now activity coefficient is nothing but A. Now activity coefficient will be expressed for aqueous species and one is a gaseous species. Just now we have seen. For aqueous species, it will be expressed in the form of the concentration, either C, either M, either square bracket. Clear? Now the C is equal to N by V, we know. Now for the gaseous species, we will express it on the basis of partial pressure. We will express it on the basis of partial pressure. Done? Now why? If suppose in the reaction other than aqueous species, if it is present, solid, let's suppose calcium carbonate solid, it is there. Done? It is converted into CaO solid plus CO2 gas. If I want to express a rate, or if I want to express the activity coefficient for this reaction, activity coefficient for this reaction for pure solids and the pure liquids, we will be taken it as 1. Why we can take it as 1? Let's suppose, that only I am explaining. It is very important to use. That's what I am saying. No. Okay. Sir, why you are expressing only for the reactant, why not the products? Okay, general example I will say you. For this one. Why only you are writing for the reactant, why not the products is your doubt. I will say, let's suppose you went to your grandma home. Okay, just example, you have went to your grandma's city or village, you have went. Okay, before going to your grandma's home, some neighbors, they have seen you. That neighbors will be identify you. I mean, like how to say, like, okay, I will explain in the Telugu. మీరు మీ నానమ్మ వాళ్ళ ఇంటికి వెళ్ళినప్పుడు ఆ ఊర్లో మీ ఎవరన్నా రిలేటివ్స్ మిమ్మల్ని చూసి ఉంటారు. క్లియర్, దే విల్ ఐడెంటిఫై యూ బికాస్ యు ఆర్ వెరీ స్మాల్. బట్ ఇఫ్ దే హ్యావ్ సీన్ యువర్ పేరెంట్స్, అదే మీ ఫాదర్నో మదర్నో చూస్తే వెరీ ఫాస్ట్లీ దే విల్ ఐడెంటిఫై, రైట్? అంటే రియాక్షన్ కూడా ఎంత ఫాస్ట్గా అవుతుంది అని చెప్పడానికి అది ఎవరిని చూసి చెప్పొచ్చు? రియాక్టెంట్స్ని చూసి మాత్రమే చెప్పొచ్చు, ప్రోడక్ట్స్ని కాదు. సో అందుకే రేట్ అనేది రియాక్టెంట్స్కి మాత్రమే ఎక్స్ప్రెస్ చేస్తాం, ప్రోడక్ట్స్కి కాదు. క్లియరా? అంటే ఇప్పుడు మీరు మీ అమ్మమ్మ వాళ్ళ ఇంటికి కానీ ఎక్కడికైనా వెళ్ళినప్పుడు మిమ్మల్ని చూసి ఐడెంటిఫై చేయలేరు. ఎవరిని చూసి ఐడెంటిఫై చేస్తున్నారు? మీ పేరెంట్స్ని చూసి ఐడెంటిఫై చేస్తున్నారు. అంటే మీ ఐడెంటిటీ ఎలా వస్తుంది? మీ పేరెంట్స్ నుంచి వస్తుంది. అంటే ఇక్కడ ప్రోడక్ట్స్ కూడా ఎంత ఫాస్ట్గా ఫామ్ అవుతుంది అని నేను చెప్పడానికి దాని ఐడెంటిటీ ఏది? దాని రియాక్టెంట్స్లో ఎంత కాన్సన్ట్రేషన్ తీసుకుంటున్నావు అనేదే నీకు కావాలి. ఓకేనా? క్లియరా? అందుకే రేట్ అనేది రియాక్టెంట్స్కి మాత్రమే ఎక్స్ప్రెస్ చేస్తాం, ప్రోడక్ట్స్కి కాదు. ఎంత ఫాస్ట్గా ప్రోడక్ట్స్లోకి కన్వర్ట్ అవుతుంది అనేది రియాక్టెంట్స్ని తీసుకునే కాన్సన్ట్రేషన్ బట్టి ఉంటుంది, రైట్? నౌ నెక్స్ట్ ఎగ్జామ్, నెక్స్ట్ వన్ హియర్. If suppose for the equilibrium reaction solid, if I take actually I have explaining why the rate is expressing for only reactants. Why only rate is expressing for the reactants. Just when you went to your grandma home, your identity will be based on your mother and father. The same thing now, the rate of the how much product it has been formed, that identity will be based on the reactants concentration what we have taken, or based on that reaction only. Okay, fine. Okay, Kalidasan, I will use English only. Done. Now let's suppose if for any reaction, if the any pure solid or pure liquid, if it is there, so why we will not express activity coefficient for the pure solids and pure liquid? Means, let's suppose this calcium carbonate I have taken 100 grams. Then now 56 gram of calcium carbonate has been formed. This is one container. Done. This is one container. In this CaCO3 solid I have taken. Done. Now number of moles will be directly proportional to volume. Number of moles will be directly proportional to the volume. Done. If the number of moles is directly proportional to the volume, molarity will be equal to number of moles, weight by volume into 1 by molecular weight. Can I write number of moles formula? Okay, I will elaborately I will write. Molarity is equal to number of moles by V in liter. Then number of moles will be weight by V in ml, will take better, V in ml into 1 by molecular weight. Done. Weight by volume will be, molarity will be equal to density by molecular weight. Density by molecular weight. Done. Here for this reaction, molecular weight of the any substance, calcium carbonate, will be fixed, that is 100. Then for this reaction, if I have taken 1 mole, this calcium carbonate, for 1 mole of calcium carbonate contain 100 grams. When this reaction is happening, 56 gram of calcium oxide is formed and 44 gram of CO2 has been eliminated. Means how much weight of CO2 has been eliminated from this container? Before, number of moles will be equal to volume, means 100 grams of calcium carbonate occupied 100 ml of volume in the container. In the same way, when this reaction is happened, 44 gram of CO2 has been eliminated from this container. Then after the 44 gram of CO2 when it has been eliminated, now I have found that this CaCO3 container volume is 56 ml. 56 ml. Initially I have found that it is 100 ml. After the reaction, when the 100 gram of calcium carbonate, when it has converted into 56 grams, 44 grams of CO2 has been eliminated, means leftover weight in this container is 56 gram, and this container volume is also 56 ml. Means here you can see, for the molarity, for the same proportion weight it is decreasing, for the same proportion volume is decreasing. Means initially 100 grams, volume of this container is 100. See, initially 100 grams of CaCO3 is there. This container volume is also 100 ml. After the reaction, from this 100 grams, 56 gram of CaCO3 has been formed. 44 gram of CO2 has been eliminated. Means same proportion. Now after the reaction happened, I have found that this container volume is 56 ml. Means 44 gram of the weight has been what? It has been eliminated. Same proportion volume has also decreased, because V is directly proportional to the N according to the Avogadro's law. Weight is nothing, number of moles is nothing but weight. You can see N is directly proportional to the weight. Means the same proportion 44 grams of the weight has been decreased in the container. Same 44 ml has been decreased, right? From the 100, 44 if you minus, it will become 56. Done. Then density is constant, right? ఇక్కడ 44 weight తగ్గింది అంటే వాల్యూమ్ కూడా అంతే తగ్గింది, అంటే డెన్సిటీ కాన్స్టెంట్ అయిపోయింది. Density has remained constant. If the density remains constant, molecular weight is constant. Molecular weight of any substance is fixed. If you take the water from sea, tap, water or anywhere, molecular weight of H2O will be 18. So same way, constant by constant, molarity will be 1. Means for the pure substance and the pure liquid, activity coefficient will be expressed it as 1. So there is no any change. Means how much weight or how much mass it is changing, at the same proportion its volume is also changing. Means its density has become constant. When its density has become constant, its activity will be expressed on the basis of, you can see, activity for the aqueous species will be expressed on the basis of molarity. Now for the reaction, molarity I got it as constant. If molarity I got it as constant, means activity coefficient for pure solids and the pure liquids also became constant, right? I hope it is clear. I hope it is clear. Should I explain once again? Should I explain once again? Should I explain once again, or is it clear? If it is clear, I will move. If it is clear, I will move. I hope it is clear. Done. Now, then we can say, alright, then we can say activity coefficient A for pure solids and pure liquids will be equal to 1. Here for pure solids and pure liquids will be taken it as 1. For if any reaction, any aqueous species if it is present, that activity coefficient for that reaction will be expressed in the form of concentration. That concentration we are expressing in the form of square bracket. If suppose if that reaction it is in the form of gaseous, that reaction activity will express in the form of partial pressure. Okay, done. Now we'll see with the how the determination of equilibrium constant. Means I will take one reaction and I will express how to express equilibrium reaction or equilibrium constant. determination of equilibrium constant. Okay, how to determine the equilibrium constant? Now we'll see. For a reaction, for a reversible reaction, I have taken one M1A1 plus M2A2 so on, equilibrium with N1B1 plus N2B2 so on. This is one equilibrium reaction. For this equilibrium reaction, now M1A1 plus M2A2 gives rise to N1B1 plus N2B2 is a forward reaction, right? This is a forward reaction. For this forward reaction, rate of forward reaction, how to express? Rate of forward reaction is equal to rate constant of forward reaction. Now, this is, let's suppose this is reaction. It is in the form of which one? It is in the form of aqueous. Aqueous means, now we will express in the form of concentration, right? Now, activity coefficient of reactant or concentration of reactant raised to the power its stoichiometric coefficient. These are stoichiometric coefficient. Now, concentration of A2. Now, A2. This is forward reaction. Done. This is forward reaction. For this same reaction, backward reaction is N1B1 plus N2B2 so on gives rise to M1A1 plus M2A2 plus so on. This is backward reaction. So how to express the rate of backward reaction? Now rate of backward reaction is equal to Kb concentration of B1 raised to the power N1, concentration of B2 raised to the power N2. Done. If suppose these reactions are in the which one? Aqueous. Now let's suppose same reaction I was considering. Now this is in the form of gaseous. Now how to express this one? Rate of forward reaction is equal to rate constant of forward reaction. Now partial pressure of reactant raised to the power its stoichiometric coefficient. Now partial pressure of reactant raised to the power its stoichiometric coefficient. If suppose this above reaction is in the form of gaseous. If it is in the form of the gaseous, you have to express in this manner. Above reaction, if it is in the form of the aqueous, then you have to express in this manner. Now this is in the form of aqueous, this is in the form of the gaseous, right? Done. Now for this one also, if suppose this reaction is in the form of aqueous, rate you have to express in this manner. Now if suppose this reaction is in the form of the gaseous, a partial pressure of B1 raised to the power N1 into partial pressure of B2 raised to the power N2. Done. This is in the form of the gaseous. Done. Normally for these two reactions, how to express in the form of the activity? Sir, actually the proper definition you have said that, see, the law of mass action at a particular temperature, rate of chemical reaction is directly proportional to the activity masses or activity coefficient or activity masses you have said, sir. But you are not at all using activity masses only. Where you are going to use this activity mass? See, activity masses for the aqueous species or aqueous reaction concentration, gaseous partial pressure. Same thing, this reaction only, for this reaction only, I will express activity coefficient. Now, for this reaction, I will express activity coefficient. How I will express the activity coefficient? Now you see. Here, this reaction is forward reaction, right? This reaction is forward reaction. Now, forward reaction activity coefficient will be expressed. Now, M1A1 plus M2A2 so on, equilibrium with N1B1 plus N2B2. Now, this is a forward reaction. So, rate of forward reaction for this one will be activity rate constant of forward reaction. Activity A its reactant raised to the power its stoichiometric coefficient. Done? Now, activity A, reactant raised to the power its stoichiometric coefficient for this one. Backward reaction. This is the backward reaction, right? For the backward reaction also we can express the activity. Now, backward reaction, rate of backward reaction is equal to, now, rate constant of backward reaction. Now, activity coefficient. For this backward reaction, these are the reactants. Okay na? Ikkada chudandi. You can see here, arrow you can see, arrow. For this arrow, these are the reactants. For this arrow, these are the reactants. So, for the backward reaction, now activity coefficient of reactant raised to the power its stoichiometric coefficient. Activity coefficient of reactants raised to the power its stoichiometric coefficient. Done? Clear? Now, rate of forward reaction and the rate of backward reaction in the form of activity we got. Now, at equilibrium we know rate of forward reaction will be equal to rate of backward reaction at equilibrium. If the rate of forward reaction and the rate of backward reaction, if it is equal, then how to write? Now, rate constant of forward reaction, rate constant of forward reactions. Now, equilibrium, only from the chemical equilibrium, for each and every section we got two questions. I mean, every section we got one question, either in the form of the either in the form of the choose a correct answer, either in the form of the integer type. Integer type questions they have given very tough. Normally the choose a correct answer one they have given nominal only, but integer one they have given very tough for the JEE. And when it comes to the NEET also they have asked in the basis of statement based question, right? So that's the reason from very slowly, elaboratedly in the statement based questions how to tackle that concept I was explaining. That's the reason only I was explaining. No, not two questions. One session we got two, because we are having the ionic equilibrium also, right? Complete from the equilibrium chapter we got two. Only from the chemical we got one. Every session we got one. Now, for the forward reaction, rate of forward reaction and the rate of backward reaction will be equal. Now, if the rate of forward reaction, if it is equal, now we know rate of forward reaction, what we got? Rate of forward reaction. Now, if it is in the form of the concentration, Kf into concentration of A raised to the power m1, concentration of A2 raised to the power m2, so on, equal to, now, rate constant of backward reaction, concentration of B1 raised to the power its stoichiometric coefficient, concentration of B2 raised to the power its stoichiometric coefficient equal. Right? Now, if you interchange, if you bring the Kb to the left hand side, now rate constant of forward reaction by rate constant of backward reaction equal to concentration of B1 raised to the power its stoichiometric coefficient, concentration of B2 raised to the power its stoichiometric coefficient by concentration of A1 raised to the power its stoichiometric coefficient, concentration of A2 raised to the power its stoichiometric coefficient, so on. Clear? Now, here rate constant of forward reaction and the rate constant of backward reaction, we will call it as a equilibrium constant. This one we call it as a equilibrium constant. Clear? Now, this equilibrium constant will play very crucial role. This equilibrium constant will play very crucial role. How it will play very crucial role means, if suppose this equilibrium reaction, if it is in the form of concentration, means this reaction whatever we have taken, this reaction if it is in the form of the aqueous, if this reaction if it is in the form of the aqueous, now this equilibrium constant we will express in the form of the Kc, because we are expressing its this reactions equilibrium constant in the form of concentration, right? So we are expressing Kf by Kb is equal to Kc. Kc in the sense equilibrium concentration. Now, equilibrium reaction concentration, then it will be equal to Kc will be equal to concentration of B1 raised to the power n1, concentration of B2 raised to the power n2 by concentration of A1 raised to the power m1 and concentration of A2 raised to the power m2. This is for the, if this reaction is in concentration. The same reaction if it is in the form of gaseous, for the same reaction if it is in the form of the gaseous. Now this same Kf by Kb we will express in the form of the Kp. We will express in the form of which one? Kp. Now this Kp will be, if this reaction is in the form of gases, now Kp equal to concentration of B1 raised to the power N1, concentration of B2 raised to the power N2 by concentration of A1 raised to the power M1, concentration of A2 raised to the power M2. Clear? I hope it is clear. I hope it is clear. For any given reaction, if the reaction is in the aqueous, you have to express in the form of the Kc. For any given reaction, if it is in the form of the gaseous, you have to express in the form of Kp. I hope it is clear, or still you are having any confusion? I hope it is clear, or still you are having any confusion? I hope it is clear, or still you are having any confusion? Clear, done. That's right. Now, after this one, now how to express the Kp and the Kc? How to express the reaction equilibrium constant for the reactions? You got it. Now, you got it. How to express the equilibrium constant for the given reaction? You got it. Now we are going to see very beautiful relation, and the n number of questions they are asking from this one. Relation between Kp and Kc. They are asking the questions from this one. Relation between Kp and Kc. So result important. Whole derivation is not at all important. No. There is not at all required the derivation. Just how to express. If the given reaction, if it is in the form of the aqueous, you have to express in the form of the Kc. If the given reaction, if it is in the form of the gaseous, you have to express in the form of, oh sorry. Kp I was expressing in the form of cancer. Sorry. Now the Kp means we have to express in the form of the gaseous, right? So partial pressure of reactants raised to the power N2 by partial pressure of A1 raised to the power M1 into partial pressure of A2 raised to the power M2. Oh sorry. Because this is in the form of the Kp. Kp means we have to express in the form of pressure. Okay? Clear? Now if it is this Kb by Kc, if the given reaction, if it is in the form of which one? It is in the form of the aqueous. If the Kp will be expressed when the reaction is given in the form of the gases. That's it. Done? Now we are going to see what is the relationship between the Kp and Kc. The same reaction I have taken. Now I have taken the same reaction. Now we are going to derive for the Kp and Kc. Only the relation is important, but there is not at all important any derivation. But even though I will derive the derivation, so that while they are asking units, you may not get confused. Okay. Now for this reaction, now we are considering this reaction is in the gaseous form. Now gaseous form means we have to express it in the form of the Kp. Kp means partial pressure of react products raised to the power its stoichiometric coefficient. Before going to this point, now you can see either equilibrium constant we are expressing on the basis of which one? You can see these are the products and these are the reactants raised to the power stoichiometric coefficient, right? So we can say equilibrium constant, we can say like this, right? Equilibrium constant, either it may be the gaseous or the aqueous. We can say products concentration by its stoichiometric coefficient by reactants concentration by its stoichiometric coefficient. Clear? We can say, right? So if you want to express any equilibrium constant for the any reaction, that it will be expressed by the concentration or gaseous of the product raised to the power its stoichiometric coefficient by its reactants. Okay, I hope it is clear. So if I want to express the Kp for this reaction, now Kp for this reaction will be partial pressure of reactant raised to the power, partial pressure of product raised to the power its stoichiometric coefficient into partial pressure of product raised to the power its stoichiometric coefficient by partial pressure of reactant raised to the power its stoichiometric coefficient, partial pressure of reactant raised to the power its stoichiometric coefficient. Now we know according to the ideal gas PV is equal to nRT. Done. If I send V to the left hand side, P is equal to NB by RT. Now molarity formula, concentration or molarity formula. Molarity is equal to number of moles by volume, right? So can I say P is equal to concentration into RT? Concentration into RT. Done. Now same this partial pressure or this pressure I am going to multiply in this reaction. Let's suppose this is reaction number 1. When I am multiplying this reaction, now listen. Here in the place of P, in the place of B, concentration of B1 into RT whole power N1 into concentration of B2 RT whole power N2 by concentration of A1 RT raised to the power M1 into concentration of A2 into RT raised to the power M2. Clear? Now if I separate the concentration terms and the RT terms, now what I will get? Kp is equal to concentration of B1 raised to the power N1, concentration of B2 raised to the power N2 by concentration of A1 raised to the power M1 into concentration of A2 raised to the power M2 into RT. Now if I make it as a common, now we can write in this manner N1 plus N2 so on minus M1 minus M2, M1 plus M2. Clear? Now this will play very crucial role. Now this N1 plus N2 minus M1 plus M2, these are stoichiometric coefficients of which one? This N1 plus N2 minus M1 plus M2 are the stoichiometric coefficients of which one? Aqueous species or gaseous species? This if you say, now half of your products minus reactant, that only I did, right? These are the stoichiometric coefficients of products and reactants. Products minus reactants, I am asking here whatever may be this circled one, N1 plus N2 minus M1 plus N2. Good. These are the stoichiometric coefficients for the gaseous only. You have to be very careful with this one. Many of the students, they will get confused here itself. Whenever the delta Ng they ask, many of the students, they are considering the liquid and the gaseous also. Don't consider the solids and the liquid one. These are the stoichiometric coefficients of only gaseous, because we have deriving the formula relation between Kp and Kc by taking the gaseous reaction, not the aqueous reaction, not the solid one. We are deriving the relation between Kp and Kc by taking the gaseous, right? So these are the stoichiometric coefficients of the gaseous only, not the solid one and the liquid one. Done. Then this is now this reaction, you can see this reaction is in the form of Kc. You can see Kc is equal to concentration of B1 raised to the power N1, concentration of B2 raised to the power N2. So in the place of this one, can I write the Kc? Now the relation will become Kp will be equal to Kc RT whole power delta Ng. whole power delta Ng. What is the meaning of here? The delta Ng means, now gaseous number of moles of gaseous products minus number of moles of gaseous reactants. This is the one very key point you have to remember. Now this is the relation between Kp and Kc. Kp is equal to Kc RT delta Ng. This delta Ng is applicable only for the gaseous products and the gaseous reactants. Okay. Now equilibrium constant Kp and Kc is independent of the following. Now how the equilibrium constant of the Kp and the Kc are, now can anyone say me? CaCO3 solid gives rise to CaO solid plus CO2 gas. Now what is the relation between Kp and Kc? What is the relation between Kp and Kc? Kp equal to Kc RT, option 1. Option Kp equal to Kc RT power minus 1. Option C, Kp is equal to Kc RT power minus 2. D, none of this above. Now answer is A. Answer is A, right? Because here for the given reaction, for the given equilibrium reaction, delta Ng will be calculated. Here this is solid. Solid we will not consider its number of moles. Now this is gaseous, 1 minus. Now reactant is in the solid. So we will not consider. 1 minus 0, it will be 1. So Kp is equal to Kc RT power delta Ng. RT power delta Ng will be 1. So answer will be A. Okay. This is some simple question to make you to understand the concept. Now by interlinking all the concept, I will give you one beautiful questions. Then you try. Next one, equilibrium constant. Equilibrium constant Kc and Kp is independent of the following. How the Kp and the Kc will not follow this one? Now with the beautiful derivations I will explain. First one, initial concentrations. First one, it will not depend upon the initial concentration of reactant and products. Okay. The second one, it will not depend upon the pressure. Third one, it will not depend upon the inert material. Now fourth one, it will not depend upon the catalyst. Now equilibrium reaction of the Kp and the Kc will change only with the temperature. How the Kp and the Kc are, how the equilibrium reaction is changing with the temperature, now we'll see. This is very, very important. Directly formula based as well as statement based question they will come. So derivation part is also important. This derivation part which I was going to do now, that it will be helpful for you in further chapters also. Done? So listen carefully whatever may be the derivation I was doing. Based on that derivation itself, easily you can predict the questions. Done? Factor influencing equilibrium constant. How the factors that are influencing the equilibrium constant? First one, just we know this is a one Arrhenius equation. K, actually this it will play very crucial role in a rate of chemical reactions. In the chemical kinetics, it will play a very crucial role. This is Arrhenius equation. But by modifying this Arrhenius equation, this is called as a activation energy. Here you may get somewhat confusion, what is this and on all, but no need of remembering this one. Just based on this one, the final formula is very important for us, and in between the derivation part, one formula you will get, that I will explain. Done. Now here, by this Arrhenius equation, we are modifying this one. Now A into e power minus delta H, because we are going to see the reaction, right? Now delta H is enthalpy of the reaction into delta. Done. Now with this is K, here we will consider it as a equilibrium constant. Now how this equilibrium constant is changing the, or how this temperature is changing the equilibrium reaction, now we will see. Now there the delta H is heat of the reaction. This one we call it as a heat of the reaction. Okay. Now how this reaction, or how the temperature is changing the equilibrium reaction, now we will see. First, temperature is only the experimental factor that influencing the equilibrium constant. First one, temperature is only experimental factor, that influencing equilibrium constant. Clear? How it is influencing, now we will see. Now we know the reaction K is equal to A e power delta H by RT, right? Done. Now this reaction we call it as a Van 't Hoff's equation. This one we call it as a Van 't Hoff's equation. Now by taking ln natural log on both sides, now what it will become? Ln K is equal to ln A into e power delta H RT, right? Clear? Now we know ln e power x is equal to x, then ln A into B, then ln e power minus x will be equal to x. So can I write it as ln K is equal to ln A minus delta H by RT. I hope it is clear, because this is ln A and this is ln e power delta H by RT. So this is in the form of ln e power x. Ln e power x will be equal to x. So this is a x. Now directly I was written. Now ln. Now if you want to convert that ln into the natural log, now 2.303 log K is equal to 2.303 log A minus delta H by RT. For our mathematical calculation purpose, now divide the 2.303. Now if you divide the 2.303 for this entire reaction, now we will get the log K is equal to log A minus delta H by 2.303 RT. 2.303 RT. Now this is a one beautiful formula we got it. Now based on this formula, one, we are going to see how it is changing the equilibrium reaction. Let based on this formula, let's suppose I was doing one reaction. Let temperature is T1 and equilibrium constant is K1. Then this reaction will become log K1 equal to log A minus delta H by 2.303 RT1. Okay. If suppose this reaction is happening at temperature T1 and equilibrium constant K1, this reaction will become 1. Let's suppose this reaction is 1. Now next I was doing some reaction at let temperature is T2 and equilibrium constant is K2. Now this reaction will become log K2 is equal to log A minus delta H by 2.303 R T2. Now this is reaction number 2. Now if you minus reaction number 2 minus reaction number 1, then what it will, directly the formula I was writing, log K2 minus log K1. Now log A will be get cancelled out, because here the log in the log K2, log A1 will be positive. Now in the log K1, in the case of log K1, this log A will be in the form of negative, so it will be directly cancelled out. So direct formula I was writing, direct formula I have written C. Now log, okay, better to not to get confused, better I will write delta H 2.303 RT2 minus log A plus delta H 2.303 RT1. Now you can see log A will be get cancelled. Now direct formula we can write log K2 by K1. We can write it as log K2 by K1 is equal to, now delta H 2.303 R is common. Delta H by 2.303 R now into 1 by T2 minus 1 by T1. Now this formula will play a very crucial role. Now based on this formula, how the equilibrium reaction is changing with the temperature, now you have to see. Okay, based on this formula, now you have to say me how the equilibrium reaction is changing with the temperature, right? I hope you got it. Now this is the formula you have to remember. Done. Now based on this formula, how the equilibrium reaction is changing. How the equilibrium reaction is changing. Let's suppose for exothermic reaction. For exothermic reaction, delta H will be positive or negative? For exothermic reaction, delta H is positive or negative? For exothermic reaction, delta H is positive or negative? For exothermic, delta H is negative. Okay. Now, for exothermic reaction, delta H is negative. This is exo, right? Now, A gives rise to B. A gives rise to exo delta H negative. Exo delta H is negative. Now, okay, this is one reaction. Now delta H is negative. For this reaction, what I am doing, temperature I am increasing, right? For this reaction, this is normally, this reaction is exo. For this reaction, I am increasing the temperature. If I am increasing the temperature, what happened to the equilibrium? Now we'll see. Now log K2 by K1, okay, equal to delta H by 2.303 R. Now here the delta H will be negative because reaction is exo. In the place of delta H, now that is negative, into 1 by T1 minus 1 by T2, right? Now when I am increasing the temperature, T2 greater than T1, right? Then can I write here T2 greater than T1 when the temperature, when I am increasing T2 greater than T1. Now this overall value will get it as negative or positive. Let's suppose this overall value, we take it as N. This entire overall value will get negative or positive. How same? This overall N value will get negative or positive when I have increased the temperature of this reaction. When I have increased the temperature of this reaction, this overall N value will get it as positive or negative. Will get negative. Why? Because T2, let's suppose this is 100. T1 is 50. Here the 100 minus 50. 100 minus 50 will be 50 by how much? It will become 5000. then overall value you will get as positive, but positive into this negative value is there, right? Here the negative value, then overall value will get it as a negative. Okay, then can I write like this, log k2 by log k1 is equal to minus n. Can I write minus n? Then if I send this log k1 to the right hand side, how to write this is in the form of log k2 minus log k1. It is in the form of log k2 minus log k1, then equal to minus n. If I send log k1 to the right hand side, then it will become, what it will become, log k1 to the right hand side, what it will become, log k1 minus n, log k1 minus n. Now for the given equilibrium reaction, it is exothermic. If I have increased the temperature, what happened to the equilibrium reaction? Equilibrium will move backward direction, equilibrium will move forward direction. Now you see, equilibrium will move forward direction or equilibrium will move backward direction, and new equilibrium constant will be decreased or new equilibrium constant will be increased. Now you see me. Now you got the answer. Based on this data, now you see. My question is, for the given equilibrium reaction, good Joshita, good. For the given equilibrium reaction, it is exothermic. If I have increased the temperature, what happened to the equilibrium constant? Equilibrium constant will be increased or decreased? Equilibrium constant will be decreased and reaction will move backward direction. Reaction will move backward direction. Now how we will see. Initially, let's suppose log k1, right? This is log k1. Now log k1 minus n. Initially, let's suppose rate constant value of k1 is 100, let us assume. Now here we will getting some negative value is 50. We got it as 50. Then k2 will become 100 minus 25, it will give you 75, right? New equilibrium constant value we got less than the equilibrium constant value initial. Initially, when I was not increasing, when I have not increasing the temperature, now the k1 equilibrium constant value for this reaction is 100. Then after, when I have increasing the temperature, then what happened? Now equilibrium constant value I got it as less. Hi Prince, hi. Now equilibrium constant value I got it as less. Means if equilibrium constant value, if I have getting less, then reaction will move backward direction or forward direction. Reaction will move backward direction. Reaction will move backward direction. Good Prince, good. Done. I hope it is clear. Then we can say yes. Now for the exothermic reaction, temperature increases, Kc value decreases. Reaction goes backward direction. Why? Backward direction, reaction go backward direction. Okay. Praneeth, one thing you remember. Now, why this reaction is going backward direction? I will explain on the basis of Kc and Qc. If I explain on the basis of Kc and Qc, there you will understand very clearly. Okay. When I am explaining, yes, Shreya. Now what Shreyas want to ask. Now endothermic, it will be forward reaction. But Praneeth, whatever may be the doubt you are having, sir, why the reaction should go backward direction after increasing the temperature? Because here, this on the basis of QC and KC I will explain. There I will explain very clearly so that you will get understand. Okay. If I started that QC and KC, it will take more time. When that concept it comes, then there I will explain with this example only. But still there, no. not on the basis of Le Chatelier principle, react on the basis of reaction coefficient. Now by increasing the temperature, equilibrium has been disturbed, right? You can consider it as a Le Chatelier principle also. Based on that also you may consider. Sir, what I wanted to say this year, JEE 25 questions, earlier 26 questions were asked like that. Can you solve JEE 25 chemistry questions after? Now, my dear friend, the nice question you have asked the Shreyas. Now, from the tomorrow onwards, from Monday onwards, I am thinking to start chapter-wise questions. Chapter-wise questions. That word only, chapter-wise questions. That chapter-wise questions and the schedule, everything I will post it in that community tab or the schedule I will post. Tomorrow I am going to start the only pure JEE mains questions of atomic structure. Then after that, classification of periodic table on Tuesday. And Wednesday I am going to take chemical bonding. Then Thursday I am going to take the mole concept plus redox. Clear? And Friday cumulative. Friday this 5 chapters cumulative. So tomorrow onwards I am going to start only the question session and chapter wise. That only chapter wise. First atomic structure, CPT, chemical bonding, mole plus redox. Chapter wise. Only JEE plus NEET. Both I will do. Question solving I will do. And Friday will be the cumulative of all these chapters, and Sunday only I will explain the concept. Sunday I will take only one shot of that chapter which I am going to take. Now the chemical bonding one shot I am going to do today, complete. I will complete today. Then next Sunday, if time permits, I will complete ionic equilibrium totally one shot. In weekdays questions, Sunday concept. Clear? Now I am having the plenty of questions, my dear friend Shreyas. I am having plenty of questions for the JEE previous year questions I am having. Right? Now, as the temperature increases, now Kc value decreasing, means new equilibrium constant value decreasing. If new equilibrium constant value decreasing, then reaction will move backward direction. Why the reaction is moving backward direction? Based on the QC and KC I will explain. Okay, don't worry. Next for endothermic reaction. For endothermic reaction, now endothermic reaction delta H is positive. Then log K2 minus log K1. For endothermic reaction, if I have increasing the temperature, then delta H value will be positive 2.303 R by 1 by T1 minus 1 by T2. Done. Now log K2 will be equal to log K1 plus some positive n value. Let's suppose this is a positive n value. This will become positive, right? Then initially if the K1 is 100, then K2 will become greater than 100, right? Greater than 100. Then what it will happen? For the endothermic reaction, if you increase the temperature, what it will happen? K equilibrium constant will be increased and the reaction moves forward direction. Reaction moves forward direction. I hope it is clear. Equilibrium constant increases, reaction moves forward direction. Now, the next very important we are going to see mode of writing equilibrium reaction. I will explain on the basis of QC and KC to you, so that there you will understand very clearly, because if I start that concept, the flow of the topic will be disturbed. Okay. Now how to write the equilibrium constant for the given reactions? Let's suppose A plus B gives rise to C plus D. This is one reaction. If I want to express the Kc for this reaction, Kc is equal to concentration of reactants raised to the power its stoichiometric coefficient, concentration of products raised to the power its stoichiometric coefficient by reactants. Now for this equilibrium reaction, if I interchange, what happened to the new equilibrium reaction? How to express the new equilibrium reaction? For this reaction, if I interchange, then C plus D equilibrium with A plus D, A plus B. Now the new equilibrium will be expressed in this manner, right? Kc dash is equal to concentration of A, concentration of B by concentration of C and concentration of D. Now new equilibrium constant after changing, this is a equilibrium reaction. This equilibrium reaction when I was interchanged. Now the new equilibrium constant Kc dash we got. This Kc dash can be expressed in this manner also. How? Kc dash is equal to 1 by Kc. This new equilibrium constant will be expressed in the form of 1 by Kc. Sir, how we can express in the form of 1 by Kc? Now you can say. Kc dash is equal to 1 by Kc, right? Now Kc means concentration of C, concentration of D. Now this will be concentration of A and the concentration of B will be in the which one? Denominator. That denominator one will comes into the numerator. Now the concentration of A and concentration of B. See, both as became same, right? If I express Kc dash 1 by Kc, this is Kc. This is Kc. New equilibrium, this equilibrium constant when I was interchanged, then new equilibrium constant also expressed in this manner. Kc dash is equal to 1 by Kc. See, Kc dash is equal to 1 by Kc. Kc is equal to this one, right? So we can write it in this manner also. Okay, this is a one reaction. Let's suppose stoichiometry representation if they have given with now this is a without stoichiometry. If suppose if they have given with the stoichiometry, A2 plus B2 equilibrium with the 2AB, if they have given with the stoichiometry, now the Kc dash will be expressed as Kc is equal to concentration of AB raised to the power 2 by concentration of A2 raised to the power its stoichiometric coefficient 1. Now for this reaction, now the Kc dash, how to express? If I was dividing by this equilibrium reaction, whatever may be the equilibrium reaction we got, this equilibrium reaction, for this equilibrium reaction, now I have multiplying 1 by 2. If I multiply by 2, then what it will happen? This one will become half A2 plus half B2 equilibrium with AB, right? This is a how the new equilibrium can be expressed. Now we'll see. When we divided it by the 2, now how the new equilibrium will be expressed. Now Kc dash will be expressed in this manner. AB whole power. Now concentration of reactants raised to the power its stoichiometric coefficient, concentration of reactant raised to the power its stoichiometric coefficient. Done. Now the new equilibrium constant also will express in this manner. Kc dash is equal to Kc whole power 1 by 2. If you express in this manner whole power 1 by 2, then new equilibrium constant will be expressed in this manner, whole power 1 by 2. Done. Clear? Now for the Kc, for this Kc, if you AB whole square by concentration of A2 and concentration of B2 whole power 1 by 2 if you multiply. Now 1 by 2 square will be get cancelled. Now 1 by 2 and here it will be the 1 by 2 and here it will be the 1 by 2. Same you will get this only. So that's the reason Kc dash is equal to Kc whole power 1 by 2. Okay. For the equilibrium reaction, if you divided it by the 2, then for the equilibrium reaction, now what you have to do? You have to multiply with the half power, you have to multiply. And many of the students, they will get confusion here. And this question also they have asked in the last year JEE Mains question. Very simple JEE Mains question. How much simple JEE Mains question they have asked from this concept? Now you see, they have given A gives rise to B. Okay, its equilibrium constant is K1 is 3. B gives rise to C. Equilibrium constant K2 is equal to 2. C equilibrium with D, K3 is equal to 5. Now D equilibrium with A. Now they are asking what is the K4. Can anyone say me what is the K4 value? What is the K4 value? Can anyone say me what is the K4 value? Can anyone say me what is the K4 value? Still that time I will search that question. The T. Is it true? Is the 30 is the answer? Still anyone? Still anyone ready to give the answer? Now the Pranit is saying it is 30. Still simple. Now what you have to do? Here the B cancel, C cancel. Now, oh not sir, C gives rise to. Now what is the reaction actually? Let me see. C gives rise to D and then D gives rise to A is asking. Clear? Now what is the here the new equilibrium constant? K1 is equal to, sorry, no need to multiply. Now the new equilibrium constant K1 is equal to concentration of B by concentration of A. Now this K2 is equal to concentration of C by concentration of B. Now the K3 will be equal to concentration of D by concentration of C. Done? Now K4 will be equal to, now the K4 will be equal to, now the K4 you need concentration of D by concentration of A. Now here when if you multiply this all the equilibrium constant K1, K2, K3, then what you will get? When you have multiplied the K1, K2, K3, now K4 what you should get? Concentration of D by concentration of A you should get. Then when you have multiplied K1 into K2 into K3, now K1 what we are having? Concentration of B by concentration of A into concentration of C by concentration of B. Concentration of B cancel. Now concentration of K3 will be D by C. Now C will get cancelled. Now at the end we got concentration of D by concentration of A, right? Now if you multiply these values, now you will get the what? You will get the answer. So 3 into 2 6, 6 into 5 30. Answer will be the 30. Answer will be the 30. I hope it is clear. Now same JEE Mains question they have asked. Now we will see what is that JEE Mains question they have asked. Now the JEE Mains 2024. JEE Mains 2024 they have asked this question. Now X equilibrium with Y. K1 is 1. Y equilibrium with Z. K2 is 2. Z equilibrium with W. K3 is 4. Now what is the value of equilibrium constant when X equilibrium with W? What is the answer? No, How come concentration of see? Oh, oh, sorry. He is asking in the form of. Okay. What is the value of concentration of K proton? Sorry. He is asking concentration of A and concentration of D. Right. Now answer is 8. Simple. Y cancel. Now here the Z cancel. Now multiply K1, K2 and K3. Then it will become 1 into 2 into 4. That it will become 8. This is JEE Mains 2024 question. In the JEE Mains 2024, they have asked this question. Same question they have asked. Right? Now. Now these are the some reactions. Now I will write one reaction. Now you have to say me what is the answer for it. The heat of the reaction. Okay. Better. Okay. Once completion of the concept, better will do combiningly the questions. This is about the mode of writing the which one? Equilibrium. Next concept that we are going to see the significance of equilibrium constant. Now what is the meaning of the significance of the equilibrium constant? What this point you have to remember. If my dear friends, by this equilibrium constant value also you can predict the given reaction. So sometimes they will give you in the question some unnecessary data they will dump, and they will give you small data or small important data they will give you. By seeing that small important data also you can predict the given reaction is irreversible or reversible, or whether the reaction is in equilibrium or not. So if the equilibrium constant value lies between 10 to the power minus 3 to 10 to the power plus 3, then the reaction is reversible. Okay, done. If the equilibrium constant value lies below 10 to the power minus 3 to the greater than 10 to the power plus 3, if equilibrium constant value lies between below 10 to the power minus 3 to above 10 to the power plus 3, reaction is irreversible. Okay, now this you have to remember. Sir, how to predict whether the given reaction is reversible or irreversible? Now you see, we know the equilibrium constant will be expressed for any given reaction is on the basis of products by reactants, concentration of products by reactants. Now case 1, if the equilibrium constant value is greater than or equal to 10 to the power 3, then equilibrium constant is directly proportional to the concentration of product or concentration of reactant. Then if the equilibrium constant value is greater than or equal to 10 to the power plus 3, when it will be happen? When the concentration of products is very greater than concentration of the reactants, right? Then see, this Kc value or this K value will be increased when the product's concentration is high. Then if the K equilibrium constant is greater than or equal to the 10 to the power plus 3 means concentration of the products is greater than the concentration of the reactants. Done. Now case 2. If I was taking the case 2, if equilibrium constant value is less than or equal to 10 to the power minus 3, then whose concentration is more dominating? Reactants 1 or products 1? Reactants 1 or product 1? reactants 1 or products 1? Reactants 1 or products 1? Now if the case K is direct as what? No. Less than or equal to, now reactants concentration will be more than the products concentration. Reactants concentration will be more than the product. Then only, right? Now the K value I should get less than 10 to the power minus 3 means now concentration of the reactants should be less. Now the more the concentration of the reactants when it is less, now equilibrium, the concentration of the reactants if it is high, then equilibrium constant will be decreased. Then based on this concept only, next we are going to start the reaction coefficient. Now, what is the meaning of the reaction quotient? Reaction quotient. What is the meaning of the reaction quotient? Reaction coefficient means QC. Right? Now, what is the meaning of the reaction coefficient? Why we are expressing the QC? Other than equilibrium time, if we express the concentration of product by concentration of reactant, that time is called QC. I hope it is clear. What is the meaning of the QC means? Now the reaction has not came to the equilibrium. Let's suppose better I will take best example for you is PCl5. Okay, not PCl5, just general example will take. A gives rise to B. Okay, now this is one reaction. Initially at a time 0, I have taken 100 moles of A, B is 0. Now after 10 minutes, after the reaction 10 minutes, from this 100 moles of A, 10 moles has been converted into products. Now 10 will be formed. Now at equilibrium, when the reaction has reached to the equilibrium, from 100, 50 moles has been converted into products. Then after time 45 minutes, let us assume. I mean this has reached at 30 minutes. Now after 45 minutes, after reaching the equilibrium, still I was continuing the reaction, I was disturbing. Then after that, from 100, some 75 moles has been converted into products. Now this 30 minutes time is the equilibrium time. This 30 minutes time is the equilibrium time. After attaining the equilibrium, I have disturbed the equilibrium reaction with some other external agent that I will explain with the Lee-Chatelain principle. At equilibrium, if I want to know concentration of reactants and the concentration of the products, that we call it as a K equilibrium. That we call it as a K equilibrium or KC. That we call it as a KC. At equilibrium time, if you want to know the concentration of the reactants and the products, we call it as a KC. Now KC is equal to 50, because products concentration is 50, reactants concentration is also 50, will be equal to 1. Done? Now at equilibrium, KC will be equal to 1. Right? Now after the reaction starting at 10 minutes. See, initially I have taken 100. Now after reaction has started and after the 10 minutes, how much reactant has been converted into the products I want to know. That one we should not say it as a KC because it has not reached to the equilibrium. That time we call it as a QC. Now the QC is equal to concentration of reactants is 90, concentration of the products is 10 and the concentration of the reactants is 90. Now, whose value will be high now? QC will be higher, KC will be higher. Now you see, at a time 10, if I want to express the reaction, rate of concentration of products by concentration of reactants, if I want to express, whose value is high at a time t is equal to 10. KC value will be higher, QC value will be higher. Now, concentration of reactants higher, concentration of products higher. At a time 10, QC value is less than KC or KC value is higher than the QC, right? Now, if the reactants concentration is high, QC value will be less. Obviously, this at the time 10, t is equal to 10 minutes. Now, QC value you will get less than 1. Now, at a time t is equal to 10 minutes, if you want to attain the equilibrium, reaction should move forward direction or backward direction. At a time 10 minutes, when you have cross-checked the concentration of reactants and the products, now the QC value you got it as less than KC. Now the reaction to attain the equilibrium, reaction should move forward direction or backward direction. To convert into more products, it should be reaction should move forward direction or backward direction. That's what I'm asking. Forward direction to convert into more products. If can I say like this, QC value if it is less than KC, reaction should move forward direction. Now, I have disturbed the equilibrium. Then after t 45 minutes, after disturbing the equilibrium reaction, then if I want to cross check QC, then concentration of reactant, a product I got it as 75, reactants is 25. Now at t 45 minutes, QC value will be greater than KC, right? Now again to attain the equilibrium, reaction should move forward direction or backward direction. After attaining the equilibrium with the external agent, I disturbed the equilibrium. After disturbing the equilibrium, at that time, after some time, I cross-checked the reactions, reactants and products. Reactants and products, when I have cross-checked, I got QC value greater than KC. Again this reaction to attain the equilibrium, now reaction should move backward direction. Okay, I hope this is clear. Done? I hope this is clear. In the same way, here, no. Where is that one? Now, here you can see. I hope the QC and KC is clear. Now, same thing for this reaction before, same thing. Before what I said, if the temperature increases, KC value will be decreases. Then KC value will be decreases means indirectly QC value will be increases. If the A gives rise to B, delta H is equal to negative. Now here T2 greater than T1. Now for this reaction I am doing what? I am increasing the temperature. If I am increasing the temperature, what happens? Now obviously KC value is decreasing. If KC value is decreasing means QC value is increasing. If QC value increasing means reaction to attain the equilibrium, again it should move to the backward direction, right? I hope it is clear. Now see, if B delta H is positive, if delta H is positive, Then if I have disturbing the equilibrium by increasing the temperature. Now what I got? Temperature increases, Kc value increasing. Kc value increasing means Qc value will be decreased. If Qc value decreases, if the Kc is greater than Qc, reaction should move forward direction. I hope it is clear. Done. Why the by increasing the temperature reaction moving backward direction? Why by increasing the temperature, why the reaction moving forward direction? Done. Now just now continuously I was taking the class from 2.5 hours. Just to give me 15 minutes break. Okay. Now the time is 6:55. We'll start the class at 7:15. Okay. Now class will start at 7:15 p.m. Okay. Today we'll complete entire chemical bonding. Okay. Today we'll complete entire chemical bonding. Sorry, chemical equilibrium. Right. Hello, anyone is in live? Hello, anyone is in live? Anyone is in live? Shh, 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 shh. Anyone is in live? Hello, my dear friends. Anyone is in live? If anyone is in live, just say me hi. Meanwhile, I will write the questions. Now say me the answer for that question. Now the question they have given, the ratio Kp by Kc, the ratio Kp by Kc for the reaction. The ratio Kp by Kc for the reaction CO gas plus half O2 gas equilibrium with CO2 gas. Clear? Now the options they have given, RT power 1 by 2 option B RT. Now option C 1 and option D 1 by root RT. Now my dear students, if anyone is in the live, just say me hi. If anyone is in the live, just say me hi. Now this is the question. Now try to say me the answer. And the next one, for this one same, and the next type of the question, just you try this question. Meanwhile, I will write the two other questions based on this data. Now the next question is, hi Joshita, hi. I hope my voice is clear, right? Joshita, is my voice is clear? I just turned off my video, but audio is clear, right? Now next one, the next question, is my audio is clear? Equilibrium constant for the reaction. Equilibrium constant for the, hello, good evening. I hope my voice is clear, right? I just turned off my video. For this one, answer is RT. Now what is asking? The ratio of Kp by Kc. No. This is the first question. No. This is the first question. This is the first question. Now, what is the answer for this question? Answer is D. What is the answer for this question? Answer is D. Now, one should solve. What is the RT value? Answer is D. RT value will be, delta Ng value will be 1 minus 1.5, right? 1.5 means 0.5. Clear? Now the 0.5 we can write it as a 1 by 2. Then minus 1 by 2. Clear? No. See, both are gases only. No. Delta Ng is 1 minus 1 plus 1.1 by 2. 1 plus 1 by 2 will be the 1.5, right? 1.5. This will become minus 0.5. So, now the Kp by Kc is asking. Now 0.5, how we can write? Now it will be equal to the 1 by 2. Done? Then Kp is equal to Kc RT minus 1 by 2. This minus 1 by 2 we can write in this manner also. Kp is equal to Kc RT whole power 1 by 2, or we can write it as a root. Now if you bring the Kc to the left hand side, then Kp by Kc will be equal to 1 by RT. Answer D. He is asking ratio of Kp by Kc. This is minus half. That minus half we can write it in the form of the Kp is equal to Kc by 1 by RT. Right? Now if you bring this Kc to the left hand side, now Kp by Kc is equal to 1 by root. Okay, done. Fine. Now the next question, the equilibrium constant of the reaction SO3 gas equilibrium with SO2 gas plus half O2 gas. Clear? Now the Kc for this reaction is equal to 4.9 into 10 to the power minus 2. Okay, now he is asking the Kc value, Kc for 2SO2 gas plus O2 gas equilibrium with 2SO3 gas is. These questions you have solved previously. Okay, fine. Now, what is the Kc for this reaction? Around 400. No, the answer they have given 4.9, B 41.6, C 49, D 416. Now, this above reaction, what he has did the interchanged 10 to the power 4 by 4.9 whole square. Yes, good. Now, this above reaction, answer is D. The concept I will say, now calculation part you do. What he is saying, this above reaction, this Kc, first one, this Kc he has interchanged. For this reaction, if you interchange, now the new Kc dash will become 1 by Kc. 1 by Kc value, how much they have given? It will be 4.9 into 10 to the power minus 2. At the same time, what he has did, he has divided by the 2. Stoichiometric coefficient he has divided by the 2. When he has divided by the 2, now the new equilibrium constant, now you have to multiply by 1 by 2. Multiply by 1 by 2. Just if you solve this one, you will get the answer. That answer we got it as 416. 416. Done. Next one. The next question, here they have given that it is for reaction SO2 gas plus half O2 gas equilibrium to give SO3 gas. Now, Kp for this reaction is 2 into 10 to the power 12 at 27 degrees Celsius and 1 atm pressure. Okay, I will explain. Now, what is the Kc value? Now, this question, see, first one, this is the reaction they have given. Now, this is the Kc for that one. But he is asking the Kc value for this one. So, above one, first one, the above reaction they have given, SO3 gas gives rise to SO2 gas plus half O2 gas. Done. Now, this is the Kc. Kc value is how much? 4.9 into 10 to the power minus 2 they have given. Done. Now, they are asking the reaction for SO2 gas plus O2 gas equilibrium with 2SO3 gas. Right? First one, if you write the Kc for this one, Kc will be SO2 plus O2 whole power half by SO3, right? Now, if you write the new Kc for this one, Kc dash will be equal to SO3 whole power 2. Now, SO2 whole power 2, for normal reaction without dividing by its stoichiometric coefficient. Without dividing by its stoichiometric coefficient, if you write stoichiometric coefficient 1 by 2, just I was interchanged the reaction. Then O2 whole power 1 by 2. Then for this new Kc dash, 1 by Kc if I write, The same thing we'll get, right? Same thing, this only we'll get. For the new Kc dash, if I divided it by this Kc, now I will get this one only. See, this SO3 is in the numerator, so denominator it will come to the numerator and we'll get the same. So can I write this Kc dash is equal to 1 by 4.9 into 10 to the power minus 2. I hope it is clear up to here. I hope it is clear up to here. ఇక్కడ వరకు క్లియర్ కదా. దాని తర్వాత నెక్స్ట్ వాట్ ఈజ్ ఆస్కింగ్, then he is asking for this reaction he has divided by the 2 stoichiometric coefficient, he has divided by the 2. Now 2, now it will become 2 and 2 it will become 1. Now here it will become 2. Done. Then if you divide the stoichiometric coefficient by 2, new equilibrium constant you have to divide it by, you have to multiply by 1 by 2. Here I explained, no. Here I explained, right? Mode of writing equilibrium. See, here if you divide, if suppose this is a reaction, for this equilibrium reaction if you interchange or if you reversed, then new Kc dash will be equal to 1 by Kc. So same thing we did here. For this reaction when I was interchange, new this equilibrium constant I was divided by 1 by Kc. Then after that next we have divided by 2. Now you can see here. Now for this reaction, if you for any equilibrium reaction, if you divide by 2, for that new equilibrium constant you have to multiply 1 by 2. Same thing we did here. For this one, if you multiply by 1 by power 1 by 2, then you will get the answer. Now the Kc dash will be equal to 1 by 4.9 into 10 to the power minus 2 whole power 1 by 2. If you do, you will get the answer. Okay. Now what is the answer for this one? Now he is asking what is the Kc value. He has given the reaction and he is asking the Kc value. What is the Kc value for this one? What is the answer you got? Okay. 10 to the power 12 approx. Okay, good. Correct only. 10 into 10 to the power 12. But actually he is asking the answer. In the form of 10 to the power 13. He is asking the answer in the form of 10 to the power 13. Answer is asking in the form of 10 to the power 13. And nearest integer R value you have to use 0.082 liter atm per Kelvin mole. Approx you got it as a 10 into 10 to the power 12. Okay, fine. Okay, got it. Now 1. Answer is 1. Correct only. Right. 1. Good. Now this KP questions are good only. One question they have asked on the basis of graph. Okay. Now questions they have asked on the basis of graph. Now the question they have given, for a reaction I2 gas, H2 gas plus I2 gas equilibrium with 2HI gas. I2 gas plus H2 gas plus I2 gas equilibrium with 2HI gas. Now which is the correct graph you have to say me. First one, the graph they have given concentration versus time. The first graph, is this graph is correct or wrong? Is this graph is correct or wrong for this reaction? For this equilibrium reaction, this graph is correct or wrong? For this equilibrium reaction, this graph is correct or wrong? Now the next graph they have given time versus concentration. This is H2, this is I2. The C. Now the next graph they have given now H2, I2, HI. Now D. Now the D they have given. This is HI. Now this is H2. Now this is I2. Now which graph is correct? For this equilibrium reaction, concentration versus time, which graph is correct? Concentration versus time, which graph is right? For this equilibrium reaction, which graph is correct? Are you there? My dear friends, are you there? Which graphs are correct? Between A and B? No. Among the A, B, C, D. This is single correct only. They have given this reaction. Okay. Now this reaction is a equilibrium reaction. Equilibrium reaction, and they are asking among these four which graph is correct? Among these four, ayo, why? Hare, just you see. By seeing the graph you can predict. No. Here concentration versus time, right? Concentration versus time. Concentration versus time graph, how we will get? How the concentration versus time graph we will get? Now the concentration versus time graph. Now reactants concentration should be decreased. No. You can see for the concentration versus time graph, reactants concentration should be decreased. Products concentration should be increased. Then after that, when they have become constant, that point, that time we call it as a equilibrium. Based on that concept, you can see here. Now here the reactants concentration is decreasing. Now the products concentration is increasing. Now one point they have both as become equal, then that time is called as a equilibrium. Based on that concept, now say me the answer. This is your JEE mains 2025 question only. This year D. You can see concentration of H2 is decreasing, concentration of I2 is decreasing, concentration of HI is increasing, and at that time it has become constant. This has become constant. Answer is D. Simple. Here you can see, here the concentration of products is increasing, at the same time concentration of the reactant is also increasing. That is not correct. Now you can see here the concentration of product is decreasing. No, for the reaction concentration of the product should be increased. Now here all are increasing. It is not at all possible. concentration of the reactant should be decreased. But here concentration of the reactant decreasing, concentration of the reactants decreasing, concentration of the products is decreasing. So it is option D. I hope it is clear. Concentration versus time is asking the graph. Next one. Next question. He has said that A gives rise to B. Okay. A gives rise to B. Now A is the forward reaction. Now B is the backward reaction. A is the forward reaction. B is the backward reaction. Now the option A he has given. Now he is asking the rate of reaction graph. Rate of reaction graph. This is saying equilibrium. This is A, this is B. Rate of reaction versus time. Okay, now B graph they have given. Right, rate of reaction versus time. Now this is a equilibrium they are saying. Now C graph they have given. Clear? Now this point they are saying it as a equilibrium. This is A, this is B, this is A, this is B. Now D no, which one is correct? D is correct, because this point rate of reaction versus time, for the rate of reaction versus time, now both rate of forward reaction and the rate of backward reaction should be equal. D is constant at this point, but here the rate has become, but they are saying that this point is the equilibrium, but that is not correct. This D is correct. Okay. Now we have did some questions based on the concept which we have studied. Now from here onwards, now the concept level will be high. Okay. Now up to now you have studied the basics of the concept. Now the NTS and the JEE and as well as NEET favorite questions will comes from this concept. Not the Lee Chatelier, but one beautiful concept will be there. Lee Chatelier also the favorite questions they will ask are the favorite topics for the NTA people, but at the same time this concept which I am going to explain, this will play very crucial role. How it will play very crucial role based on this concept, how many questions they have asked in the NEET as well as the JEE. Now I will see. First I will explain the concept. After explaining the concept, based on that one I will give you the question. High level questions will be very high level. JEE mains only, not the advanced or not any of the book. Mains only. See how much high level they are asking the questions. If you remember the concept which I am going to explain now, just formula you remember, whether the given reaction delta Ng you just find out. First to see the reaction, first to find the delta Ng, and if you remember the formula, within less than 1 minute or less than 1 minute you can solve the question. If not, you have to, it will take more than 5 minutes. See how to solve that question very fastly. That concept I am explaining. Actually that is a question, but that question I am explaining in the form of concept. Then after that I will give the question. See, equilibrium constants. Equilibrium constant. If delta Ng is equal to 0, if delta Ng greater than 0, if delta Ng less than 0. This type of the reaction they have given. They are asking the what is the Kp and what is the Kc. let's suppose first one we are going to deal with the given reaction delta Ng is 0 and what is the Kp and what is the Kc. If delta Ng is greater than 0, if 2Hi gas equilibrium with H2 gas plus I2 gas, okay, done. Now its overall delta Ng value will be 0. Why? 1 plus 1 minus 2. 1 plus 1 2, 2 minus 2 0. Delta Ng is 0. For this reaction, initially at a time t is equal to 0, I am taking A moles. Clear? Now 0 0 has been formed. When this reaction has been reached to the equilibrium, from A moles some X moles has been dissociated. X by 2 moles has been formed. X by 2 moles has been formed. Sir, how this X by 2 moles has been formed? Now you may get it out. You can see as per the given reaction, as per this given reaction, 2 moles of Hi giving 1 mole of H2 and I2. From this A moles, X moles has been dissociating. For the X moles, how much moles it should be formed? X by 2 it should be formed, right? And here also 1, right? X by 2 it should be formed. Means, sir, here this reaction you may get a doubt. Sir, as per the stoichiometry, it is 2 moles. But you are taking the A moles only. Sir, why you are not going to take the A moles? Now you may get a doubt. Hello, my dear friends. Now, the one who is in the live, just say me hi once, so that this concept is very, very important and it will make you lot of confusion. And NTS favorite questions will be from this concept only. Pranit is in live. Still any other? Once say me hi. Now, right. Listen. Here, why I have written this X by 2 means, good. Listen. Now, why I have written this X by 2 here means, what we are expressing actually for this reaction, how much rate means how much reactant has been converted into the products. Now, I want to express, right? అంటే ఇప్పుడు ఈ రియాక్షన్కి ఏదైతే రియాక్షన్ ఉందో ఈ రియాక్షన్ ఎక్స్పెరిమెంటల్గా అది రియాక్షన్ అట్లా ఉంది, కానీ థియరిటికల్గా అది రియాక్ట్ అయినప్పుడు దాని నెంబర్ ఆఫ్ మోల్స్తో రియాక్ట్ అవ్వదు. అంటే ఎగ్జాంపుల్ ఏంటంటే, లెట్ సపోజ్ క్రికెట్ ఒక మన టీమ్ ఇండియా ఉంది. ఓకే, టీమ్ ఇండియాలో ఎంతమంది ప్లేయర్స్ ఉంటారు? 11 ప్లేయర్స్ ఉంటారు. ఇప్పుడు ఈ ఒక మ్యాచ్ విన్ అవ్వాలి అని అంటే ఇట్ విల్ బి డిపెండ్ అపాన్ ద 11 ప్లేయర్సా కదా? అంటే ఏదైనా మ్యాచ్ డిపెండ్ అవ్వాలి అని అంటే 11 ప్లేయర్స్ మీద డిపెండ్ అవుతుంది. ఎప్పుడు మన క్రికెట్ మ్యాచ్కి టాస్ పడక ముందు, అంటే టాస్ పడనంతసేపు మ్యాచ్ విన్ అవ్వాలి అని అంటే అది 11 ప్లేయర్స్ మీద డిపెండ్ అవుతుంది. అంటే మనము ఇనిషియల్గా ఏదైనా రియాక్షన్ స్టార్ట్ చేయక ముందుకు అది దాని నెంబర్ ఆఫ్ మోల్స్ మీద డిపెండ్ అవుతుంది. కానీ మన క్రికెట్ టీంలో టాస్ పడ్డ తర్వాత, లెట్ సపోజ్ అవర్ టీమ్ ఇండియా ఈస్ గోయింగ్ టు బౌల్ ఫస్ట్, అంటే బౌలింగ్ వేస్తుంది అనుకుందాం. అంటే మన ఫస్ట్ ఇన్నింగ్స్ అయిపోయింది, మన ఇండియా బౌలింగ్ చేసింది, ఫస్ట్ ఇన్నింగ్స్ అయిపోయిన తర్వాత మన ఇండియా దే హ్యావ్ కేమ్ టు బ్యాట్. సెకండ్ ఇన్నింగ్స్లో మన బ్యాటింగ్కి వచ్చినారు. లెట్ సపోజ్ అవర్ టార్గెట్ ఈస్ 298. మరి ఇప్పుడు ఈ 298 టార్గెట్ని చేజ్ చేసేది ఇట్ విల్ బి డిపెండ్ అపాన్ ద బ్యాటర్సా బౌలర్సా? మన టీమ్ ఇండియా బిఫోర్ టాస్ మన మ్యాచ్ విన్నింగ్ విల్ బి డిపెండ్ అపాన్ ద 11 ప్లేయర్స్. కానీ టాస్ పడ్డ తర్వాత if our team is chasing, that it will be depend upon the only 5 or 6 batters. It will be depend upon the batsmen only mainly. అంటే మనం కూడా మన రియాక్షన్ స్టార్ట్ చేయక ముందుకు అది దాని మోల్స్ ఆ రియాక్షన్ యొక్క మోల్స్ మీద డిపెండ్ అవుతుంది. కానీ అది ఎప్పుడైతే రియాక్షన్ స్టార్ట్ అయిందో ఆ రియాక్షన్లో ఉన్న దాని మోల్స్ మీద డిపెండ్ అయితలేదు, ఓన్లీ సర్టెన్ ఫ్యూ మోల్స్ మీద డిపెండ్ అవుతుంది. అందుకే దాన్ని అక్కడ ఏ తీసుకున్నా. ఐ హోప్ ఇట్ ఈస్ క్లియర్. అర్థమైందా? ఐ హోప్ ఇట్ ఈస్ క్లియర్. అందుకే ఇక్కడ నేను 2 ఎందుకు తీసుకోలేదు అని అంటే, సార్ ఇక్కడ 2 మోల్స్ ఉంది కదా, మీరు 2 మోల్స్ తీసుకోవాలి, ఏ మోల్స్ ఎందుకు తీసుకున్నారు అంటే, యాక్చువల్గా రియాక్షన్ చూడడానికి దాని 2 మోల్స్ మీద డిపెండ్ అవుతుంది, కానీ అది ఎక్స్పెరిమెంటల్లో రియాక్షన్ అయినప్పుడు దాని 2 మోల్స్ మీద డిపెండ్ అవుతలేదు, సర్టెన్ ఒక ఫ్యూ మోల్స్ మీద డిపెండ్ అవుతుంది. అదేందో నాకు కూడా తెలియదు కాబట్టి ఏ తీసుకున్నా. అంటే నార్మల్లీ దే విల్ మెన్షన్ ఇన్ ద క్వశ్చన్, అది ఆ ఎంత మోల్స్ ఆఫ్ రియాక్టెంట్ తీసుకున్నాడు అని వాడు క్వశ్చన్లో మెన్షన్ చేస్తాడు. సో మనం జనరల్గా టాపిక్ ఎక్స్ప్లెయిన్ చేయాలి కాబట్టి ఏ తీసుకున్నా. నాకు ఐ హోప్ ఇట్ ఈస్ క్లియర్. జస్ట్ ఎగ్జాంపుల్ అమ్మా, చిన్న ఎగ్జాంపుల్. మన క్రికెట్లో బిఫోర్ టాస్ win of the match will be 11 players. After the toss win of the match will be either bowlers or batters. అంటే ఇక్కడ కూడా అంతే, రియాక్షన్ స్టార్ట్ చేయక ముందుకు ఇట్ విల్ బి డిపెండ్ అపాన్ 2 మోల్స్, కానీ రియాక్షన్ స్టార్ట్ అయిన తర్వాత అది 2 మోల్స్ మీద డిపెండ్ అయితలేదు, ఇట్ ఈస్ డిపెండింగ్ అపాన్ ఓన్లీ సర్టెన్ ఏ మోల్స్. సో సర్టెన్ ఏ మోల్స్, in that certain A moles, some X moles has been dissociated. Ante as per the general reaction, 2 moles is giving 1 mole of H2 and 1 mole of I2. Then from the A moles, some X moles has been converted into product. ఈ 2 లో నుంచి X product లో కన్వర్ట్ అయిపోయింది. X కన్వర్ట్ అయిపోతే మరి ఇప్పుడు ఎంత ఇస్తుంది? X/2 కదా. ఇక్కడ వరకు ఐ హోప్ ఇట్ ఈస్ క్లియర్ ఫర్ ఎవ్రీవన్. ఇది ఒక్కదానికి చెప్పినా మిగతా వేరే రియాక్షన్లకు చెప్పండి, డైరెక్ట్ రాసేస్తా. ఐ హోప్ ఇట్ ఈస్ క్లియర్ ఫర్ ఎవ్రీవన్. ఐ హోప్ దిస్ ఈస్ క్లియర్ ఫర్ ఎవ్రీవన్. ద వన్ హూ ఈస్ లిజనింగ్ ద లైవ్, ఐ హోప్ ఇట్ ఈస్ క్లియర్. యాజ్ పర్ ద రియాక్షన్ 2 ఈస్ గివింగ్ 1. ఎస్, డన్. రైట్, ఫైన్. నౌ దిస్ ఈస్ ఈక్విలిబ్రియం రియాక్షన్. రైట్, నౌ దిస్ ఈస్ ఈక్విలిబ్రియం రియాక్షన్. For this equilibrium reaction, if I want to calculate total number of moles, for this equilibrium reaction, when the reaction has reached to the equilibrium, now I want to calculate the total number of moles. How to calculate the total number of moles? Total number of moles will be equal to moles of HI, A minus X, plus moles of H2, X/2 plus X/2. Now total number of moles will be equal to, fastly, total number of moles will be equal to total number of moles will be equal to, now the total number of moles will become A, right? Why? X/2 plus X/2 will be equal to X, right? Done. Then it will be equal to A. Total number of moles for the given reaction will be A. Done. Clear? You can write half plus half, it will become 1x plus x, and x minus x, it will be cancelled. Now n total will be A. Now for this reaction I want to express Kc. How to express the Kc? For that reaction I want to express the Kc. Kc will be equal to concentration of H2 by concentration of I2 raised to the power concentration of Hi whole square, right? Because its stoichiometric coefficient is 2. Done. Products concentration by reactants ante, products concentration by reactants concentration. Now concentration is nothing but number of moles by volume. Ikkada number of moles e kada ivi, these are moles only, right? These are moles, but I need concentration. So for the equilibrium constant I need concentration, but I am having moles. So to get the concentration I have to divide it by volume. If I have divided by the volume, then it will become concentration, right? Now Kc will be equal to concentration of H2, its number of moles will be X/2 by V. into concentration of I2. Its number of moles will be x by 2 by V by concentration of HI will be how much? Concentration of A minus X by V whole square, right? Now you can see here this V and this V will be cancelled because V square and it will become V square. Then Kc will be equal to x square by 4a minus x whole square. Can I write? This is clear or not? 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 Done. Okay, fine. Now the same reaction if I want to express the Kp, but Kp will be expressed on the basis of Dalton's law. My dear friends, you have to be very careful with the Dalton's law. What is the meaning of the Dalton's law? Dalton's law has said that partial pressure of any individual gas will be equal to mole fraction into P total. Partial pressure of any gas will be expressed as mole fraction of that gas in the container and the pressure of that container, Pt, right? Now, if I want to express the Kp for this reaction, Kp of H2, partial pressure of H2, partial pressure of I2 by partial pressure of Hi whole square. Done. Now, if I want to express P total, if I want to express the P total, now mole fraction of any substance will be equal to number of moles of A by Nt, right? Number of moles of A by Nt. So if I want to express the Kp for this one, Kp will be equal to partial pressure of H2. Partial pressure of H2. Now its number of mole fraction will be x by 2 by A because Nt is A, right? Into Pt. Into Pt. Now Pt, here Pt is this one. If suppose total pressure, if suppose this is a aqueous species, number of moles. If suppose this is a gaseous species, total number of or partial pressure of the reaction or container, that also it will become A, right? So Pt also A cancel. N total, P total will be cancelled. Next, x by 2 Pt by A Pt will be cancelled. Next, by if you are getting confusion, here also you can eliminate A minus X by A whole square into Pt square. Now Pt square, A square will be get cancelled. Now the Kp formula will become x square by 4 into A minus X whole square. Means for the delta Ng, if it is 0, see Kc and Kp is equal to 0. Which one? If the delta Ng is equal to 0, Kp will be equal to Kc. Kp will be equal to Kc. Now, if the delta Ng is greater than 0, PCl5 gas equilibrium with PCl3 gas plus Cl2 gas. Okay na? Right? This reaction if they have given, how to express the Kc for this one? Same, directly I was writing A minus X A. Nt how much? This is equilibrium. Nt how much? What is the Nt for this one? N total for this reaction. XX kada sir. Oh, sorry. Correct. Sorry. XX, correct. And now what is the N total for this one? Correct. Sorry. Now, what is the N total for this one? What is the N total for this one? What is the N total for this one? No. N total will be A minus X plus X, right? X cancel. It will be A plus X, right? Now the N total for this reaction will be A plus X. Now, after getting the a plus x, then if you write the kc, for this one, how to write? X by v into x by v by a minus x by a plus x, right? A minus x by a plus x by v, right? I hope it is clear. Oh, sorry. A minus x, a minus x by v, then it will be equal to x square by v square by a minus x by v. Here one v and one v will be get cancelled. Now the kc will be equal to x square by, how much it will become? X square by a minus x into v. Now this is a kc formula for the delta ng greater than 0. So delta ng greater than 0, kc will be equal to how much? X square by a minus x into v, right? Now if I want to express the kp for the same reaction, now kp also same, at a equilibrium PCl5 a minus x equilibrium with PCl3 gas, that it will be x plus Cl2 gas. Now Pt will be equal to a plus x. Right? Now if I want to express the Kp for this reaction, how to express the Kp for this reaction? Kp is equal to number of moles x by total number of moles a plus x into Pt, right? Plus x plus a plus x into Pt for Cl2 by a minus x by a plus x into Pt for the Kp, right? Now how to eliminate this one? How to eliminate? One a plus x Pt, one a plus x Pt can be cancelled. Then the overall reaction will become x square by a plus x into a minus x. We can write it as a square minus x square into Pt. This is a Kp formula. I hope it is clear. Kp and Kc formula. Kc formula ఏమొచ్చింది? Kc is equal to x square by a minus x into v. Kp formula we got it as x square by a square minus x square into Pt. Okay na? I hope it is clear for this one. Ikkada x we can say it as degree of dissociation alpha also. Okay na? X ni alpha అని కూడా అనొచ్చు. Okay na? Don't get confused. Sir, x ఏ తీసుకున్నారు, ఆల్ఫా మోల్స్ కూడా డిసోసియేట్ అయింది. ఇక్కడ వరకు క్లియర్ కదా? Based on this one, now I will give you one question. Now you see me. Based on this concept, ఇదే కేసీ కేపీ నుంచి నేను ఒక క్వశ్చన్ ఇస్తా, చెప్పండి. డైరెక్ట్లీ మీరు చెప్పొచ్చు. ఈ ఫార్ములాస్ గుర్తుంటే మీరు డైరెక్ట్లీ చెప్పొచ్చు, లేకపోతే మళ్ళా ఫస్ట్ నుంచి చేయాలి. ఎస్ చెప్పమ్మా ప్రణీత్, వాట్ ద డౌట్ యూర్ హ్యావింగ్? ఏ గ్యాస్ ఈక్విలిబ్రియం విత్ what is the reactant stoichiometry? Reactant stoichiometry is one only. That also I will explain. What happens to the reactant stoichiometry changes? I will explain. Reactant stoichiometry change అయితే సార్ కేపీ కేసీ కూడా చేంజ్ అవుతుంది. ఇప్పుడు PCl5 ప్లస్ PCl3 ప్లస్ Cl2 ఉంది కదా, ఇప్పుడు అదే డెల్టా ఎన్జీ గ్రేటర్ దాన్ 0. ఇప్పుడు ఈ రియాక్షన్కి డిఫరెంట్ కేసీ కేపీ వస్తుంది. ఏది? N2O4 గివ్స్ రైస్ టు 2NO2 గ్యాస్. ఇక్కడ డెల్టా ఎన్జీ గ్రేటర్ దాన్ 0నే. ఎందుకు? 2 - 1 డెల్టా ఎన్జీ గ్రేటర్ దాన్ 0నే. డెల్టా ఎన్జీ గ్రేటర్ దాన్ 0, మరి స్టైకియోమెట్రిక్ కోఎఫిషియంట్ రియాక్టెంట్ సైడ్ ప్రోడక్ట్ సైడ్ స్టైకియోమెట్రిక్ కోఎఫిషియంట్ చేంజ్ అయినాయి. మరి ఇక్కడ కేపీ కేసీ ఎట్లా వస్తుందో చూద్దాం. ఏ - x, 2x ఈక్విలిబ్రియం దగ్గర. మరి ఇప్పుడు కేసీ ఎట్లా రాస్తాం? కేసీ విల్ బి ఈక్వల్ టు 2x బై వి హోల్ స్క్వేర్ బై ఏ మైనస్ ఎక్స్ బై వి, ఏ మైనస్ ఎక్స్ బై వి. దెన్ ఇక్కడ కేసీ ఏమైపోతుంది, డైరెక్ట్ రాసేస్తున్నాం 4x స్క్వేర్ బై ఏ మైనస్ ఎక్స్ ఇంటూ వి. అంటే ఇక్కడ కేసీ ఏమవుతుంది, ఇక్కడ రియాక్టెన్స్ చేంజ్ అయినప్పుడు ఒక 4 ఒక్కటి రాలే అంతే, బట్ ఎవ్రీథింగ్ ఈజ్ సేమ్. ఎక్కడ ఈ రియాక్షన్కి రియాక్టెన్స్ సైడ్ ప్రోడక్ట్ సైడ్ 2 ప్రోడక్ట్స్ ఉంటే కేసీ ఎక్స్ స్క్వేర్ బై ఏ మైనస్ ఎక్స్ ఇంటూ వి వచ్చింది. అదే ప్రోడక్ట్ సైడ్ 2 మోల్స్ ఉంటే జస్ట్ 4 ఒక్కటి ఎక్స్ట్రా యాడ్ అయింది అంతే. క్లియరా? కేపీకి కూడా అంతే, నువ్వు కేపీ క్యాలిక్యులేట్ చేసినా కూడా అంతే. కేపీకి ఏమవుతుంది అంటే కేపీ విల్ బి ఈక్వల్ టు 4x స్క్వేర్ బై ఏ స్క్వేర్ మైనస్ ఎక్స్ స్క్వేర్ ఇంటూ పీటీ అవుతుంది అంతే. దట్ వాట్ ఐఎమ్ సేయింగ్, వై టు వేస్ట్ యువర్ టైమ్ ఇన్ ద ఎగ్జామ్. నేను చెప్పేదే అది. మీరు ఎగ్జామ్లో ఈ డెరివేషన్ డిరైవ్ చేసి మీరు టైం వేస్ట్ చేసుకోవడం ఎందుకు? అదే మీరు డైరెక్ట్ డెల్టా ఎన్జీ గ్రేటర్ దాన్ లెస్ దాన్ చూసేసుకొని ఆన్ ది స్పాట్లో సాల్వ్ చేయొచ్చు అంటున్నాను నేను. మీరు ఎగ్జామ్లో సాల్వ్ చేసి ఈ ఫార్ములాస్ అన్నీ మీరు గుర్తుపెట్టుకుంటే ఎగ్జామ్లో లెస్ దాన్ 30 సెకండ్స్లో క్వశ్చన్ సాల్వ్ చేయొచ్చు. నేను చెప్పేది అది. మీరు ఎగ్జామ్లో సాల్వ్ చేసుకుంటారంటే నేను కాన్సెప్ట్ ఎందుకు చెప్తా, ఇదంతా టైం వేస్ట్ కదా. దాని బదులు వేరే కాన్సెప్ట్ చెప్పుకున్న వీ కెన్ క్లియర్ రైట్. ఎగ్జామ్లో మీ టైం సేవ్ చేయడం కోసమే కదా ఇక్కడ ఈ కాన్సెప్ట్ అంతా ఎక్స్ప్లెయిన్ చేస్తున్నా. అంటే ఎట్ ద ఎండ్ మీరు ఏమంటున్నారంటే సార్ మేము గుర్తుపెట్టుకోము ఫార్ములాస్, మేము టైం వేస్ట్ చేసుకుంటాం అంటున్నారు. టైం వేస్ట్ చేయొద్దనే కదా నాన్న, ఫాస్ట్ క్యాలిక్యులేషన్ కోసమే కదా. ఓకేనా? ఇప్పుడు డెల్టా ఎన్జీ గ్రేటర్ దాన్ 0కి కేపీ కేసీ ఫార్ములాస్ మీకు గుర్తున్నాయి. ఇప్పుడు నేను ఒక క్వశ్చన్ అడుగుతా, నాకు ఆన్సర్ చెప్పు. ఓకే నేను ఒక క్వశ్చన్ అడుగుతా, ఇదే ఫార్ములా బేస్డ్ ఒక క్వశ్చన్ అడుగుతా, నాకు ఆన్సర్ చెప్పండి. ఇప్పుడు ఏ గివ్స్ రైస్ టు బి ప్లస్ సి గ్యాస్. ఓకేనా? వాట్ యు ఆర్ సేయింగ్, నౌ కన్సిడర్ ద ఈక్విలిబ్రియం రియాక్షన్ ఆఫ్ ద గ్యాస్ ఫేస్. ఇది గ్యాస్ ఫేస్ రియాక్షన్. దీనికి ఏమంటున్నాడు అంటే P is total pressure. ఓకేనా? దాని తర్వాత KP is the equilibrium pressure. మనం ఇక్కడ x బదులు ఆల్ఫా ఇచ్చిండు క్వశ్చన్లో అంతే. ఆల్ఫా ఈస్ డిగ్రీ ఆఫ్ డిసోసియేషన్. ఓకేనా? దెన్ విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈస్ ట్రూ అంటున్నాడు. ఏ స్టేట్మెంట్ ట్రూ అని అడుగుతున్నాడు. ఆప్షన్ ఏ ఏమి ఇచ్చినాడంటే ఇఫ్ పి వాల్యూ ఈస్ ఎక్స్ట్రీమ్లీ హై compared to KP, alpha value will be equal to 1 అంటున్నాడు. అంటే alpha value will be nearly equal to the 1 అంటున్నాడు. ఈ స్టేట్మెంట్ కరెక్టా రాంగా? నాకు చెప్పండి. జస్ట్ సింపుల్గా ఏం చేసేది లేదు. ఫస్ట్ డెల్టా ఎన్జీ తీయండి. డెల్టా ఎన్జీ విల్ బి గ్రేటర్ దాన్ 0. మరి ఇక్కడ ఏం అడుగుతున్నాడు, గ్యాసియస్ ఫేస్ రియాక్షన్ అంటున్నాడు. గ్యాసియస్ ఫేస్ రియాక్షన్ అంటే కేపీ రాయండి. మనకి ఇక్కడ కేపీ ఏమున్నది, గ్యాసియస్ ఫేస్ రియాక్షన్కి కేపీ ఎక్స్ స్క్వేర్ బై ఏ స్క్వేర్ మైనస్ ఎక్స్ స్క్వేర్ ఇంటూ పీటీ ఇంటూ కేపీ. అంటే మనం ఇక్కడ రాయాల్సింది ఏంది, కేపీ ఈజ్ ఈక్వల్ టు ఆల్ఫా స్క్వేర్ మైనస్ ఏ స్క్వేర్ మైనస్ ఆల్ఫా స్క్వేర్ ఇంటూ పీటీ. దాన్ని ఇంటర్ కన్వర్ట్ చేయండి. ఇంటర్ కన్వర్ట్ చేస్తే మనకేమొస్తుంది, మనకి ఇక్కడ ఇంటర్ కన్వర్ట్ చేస్తే ఏమొస్తుంది, కేపీ ఇంటూ ఏ స్క్వేర్ మైనస్ ఆల్ఫా స్క్వేర్ ఈజ్ ఈక్వల్ టు ఆల్ఫా స్క్వేర్ అవుతుంది. అంతే కదా? అంటే ఇప్పుడు జస్ట్ ఆల్ఫా స్క్వేర్ ఇంటూ పీటీ అవుతుంది. ఇప్పుడు ఇక్కడ ఆల్ఫా వెరీ లెస్ దాన్ నెగ్లిజిబుల్ 1 అయింది అనుకో, ఆల్ఫా వాల్యూ ఈస్ వెరీ వెరీ లెస్ దాన్ 1 అంటే ఇప్పుడు ఏమైపోతుంది, ఈ ఓవరాల్ వాల్యూ 1 అయిపోతుంది. ఓవరాల్ వాల్యూ 1 అయిపోతే ఆల్ఫా ఈజ్ ఈక్వల్ టు అండర్ రూట్ కేపీ బై పీటీ రాయొచ్చు. ఇప్పుడు దీన్ని బేస్ చేసుకొని మనం చెప్పాలి. నాకు ఇప్పుడు చెప్పండి. ఇప్పుడు ఆల్ఫా ఈజ్ ఈక్వల్ టు రూట్ కేపీ బై పీటీ వచ్చింది. అకార్డింగ్ టు ఇప్పుడు పీ వాల్యూ ఎక్కువ అయితే ఆల్ఫా వాల్యూ టెన్స్ టు 1 అంటున్నాడు. అది ట్రూ ఆ ఫాల్సా? ఈజ్ ఇట్ ట్రూ ఆర్ ఫాల్స్? ఈ స్టేట్మెంట్ కరెక్టా రాంగా? ఈజ్ దిస్ స్టేట్మెంట్ ఈస్ కరెక్ట్ ఆర్ రాంగ్? ఫర్ ద గివెన్ రియాక్షన్ ఫాల్స్, అంతే కదా. వాట్ ఈస్ సేయింగ్, ఇఫ్ ద పీటీ వాల్యూ ఈస్ ఎక్స్ట్రీమ్లీ హై, ఈ పీటీ వాల్యూ ఒక 1000 అనుకుంటే ఆల్ఫా వాల్యూ ఆబ్వియస్లీ విల్ బి డిక్రీజ్. అది 10:1కి రాదు. సో ఆల్ఫా వాల్యూ ఇస్ రాంగ్, అంటే అది రాంగ్. పోనీ ఇది అర్థమైందా? ఇది ఎలా వచ్చిందో, ఆల్ఫా ఈజ్ ఈక్వల్ టు కేపీ బై పీటీ, మనం x² బదులు ఆల్ఫా అనుకుంటున్నాం అంతే. ఇక్కడ ఏ కాన్సన్ట్రేషన్ కదా సార్, ఆ స్క్వేర్ మైనస్ ఆల్ఫా స్క్వేర్ హౌ టు బి 1. ఓ ఇదా, సరే. ఇప్పుడు ఫర్ ద గివెన్ ఇక్కడ ఏమంటున్నాడు, పీ టోటల్ కేబీ ఆల్ఫా ఈజ్ ఈక్వల్ టు డిగ్రీ ఆఫ్ డిసోసియేషన్. ఇక్కడ ఆల్ఫా వాల్యూ నార్మల్లీ డిగ్రీ ఆఫ్ డిసోసియేషన్ విల్ బి ఫర్ ద వీక్ ఎలక్ట్రోలైట్ అండ్ ద వీక్ వన్ విల్ బి టేకెన్ యాజ్ 1. అంటే ఇక్కడ డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా విల్ బి వెరీ వెరీ లెస్. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా వెరీ లెస్ అంటే ఇప్పుడు ఇక్కడ కాన్సన్ట్రేషన్ కదనా, ఈ కాన్సన్ట్రేషన్ నేను 1 తీసుకుంటా ఇనిషియల్. లెట్ సపోజ్ అంటే ఈ క్వశ్చన్ సాల్వ్ చేయడం కోసం 1 తీసుకుంటా, ఓకేనా. ఈ కాన్సన్ట్రేషన్ 1 తీసుకుంటే ఈ ఆల్ఫా వాల్యూ వెరీ వెరీ లెస్ దాన్ 1, ఆల్ఫా డిగ్రీ ఆఫ్ డిసోసియేషన్ తక్కువ అయిపోతే ఈ ఆల్ఫా వాల్యూ నెగ్లెక్ట్ చేసేస్తే కేపీ అయిపోతుంది కదా, కేపీఏ కదా అయిపోయేది. క్లియరా? అర్థమైందా? ఇప్పుడు ఇక్కడ కాన్సన్ట్రేషన్ కదా ఏ అంటే నెంబర్ ఆఫ్ మోల్స్ కదా. ఇనిషియల్గా నేను దీనికి 1 మోల్స్ అని తీసుకుంటే ఇది 1 మైనస్ ఆల్ఫా స్క్వేర్ అవుతుంది. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా ఇస్ వెరీ వెరీ నెగ్లిజబుల్ ఆర్ వెరీ వెరీ లెస్ దాన్ 1. అంటే లెస్ దాన్ 1 అంటే ఇది 1 అయిపోతుంది, నెగ్లెక్ట్ చేయొచ్చు. దీన్ని నెగ్లెక్ట్ చేసేస్తే ఇది ఓవరాల్ వాల్యూ కేపీ అయిపోతుంది. ఈ ఆల్ఫా ఈజ్ ఈక్వల్ టు రూట్ని తీసుకొచ్చి పీటీని తీసుకొస్తే ఆల్ఫా ఈజ్ ఈక్వల్ టు రూట్ కేపీ బై పీటీ. అంటే పీటీ అంటే పీ టోటల్, ఇక్కడ పీ అయిపోతుంది. పీ ఎక్స్ట్రీమ్లీ వాల్యూ అయిపోతుంది అంటే ఆల్ఫా వాల్యూ తగ్గిపోతుంది. అంటే ఆ స్టేట్మెంట్ 1 రాంగ్. స్టేట్మెంట్ 2 ఇచ్చినాడు ఇంకొకటి. స్టేట్మెంట్ 2 ఇచ్చినాడు. స్టేట్మెంట్ 2 ఏమి ఇచ్చినాడు అంటే ఇదే జేఈఈ మెయిన్స్ 2025 క్వశ్చన్ ఇది కూడా. స్టేట్మెంట్ 2 ఏమి ఇచ్చినాడు అంటే ఇఫ్ కేపీ వాల్యూ ఈస్ హై, ఎక్స్ట్రీమ్లీ హై అంటున్నాడు. ఇఫ్ కేపీ వాల్యూ ఈస్ హై కంపేర్డ్ టు పీ, ఆల్ఫా బికమ్ మచ్ లెస్ దాన్ యూనిట్. అంటే ఆల్ఫా వాల్యూ బికమ్స్ వెరీ లెస్ అంటున్నాడు. ఈ స్టేట్మెంట్ కరెక్టా రాంగా? ఈ ది స్టేట్మెంట్ ఈస్ ట్రూ ఆర్ ఫాల్స్? ఈ స్టేట్మెంట్ కరెక్టా రాంగా? ఈజ్ ది స్టేట్మెంట్ ఈస్ ట్రూ ఆర్ ఫాల్స్? ఈజ్ ది స్టేట్మెంట్ ఈస్ ట్రూ ఆర్ ఫాల్స్? ఎట్లా? ఆల్ఫా ఈస్ రూట్ ఆఫ్ కేపీ బై పీ. ఇప్పుడు ఇక్కడ కేపీ పెరిగితే ఆల్ఫా షుడ్ బి, కానీ అక్కడ రాంగ్ ఇచ్చినాడు. ఆప్షన్ సి ఏమి ఇచ్చినాడు అంటే వెన్ పీ ఇంక్రీజెస్ ఆల్ఫా ఇంక్రీజెస్ అంటున్నాడు. వెన్ పీ ఇంక్రీజెస్ ఆల్ఫా ఇంక్రీజెస్ అంటున్నాడు. ఆప్షన్ సి కరెక్టా రాంగా? Is it true or false? Hey, when P increases, alpha increases. Alpha is equal to under root KP by P కదా. ఇప్పుడు P ఇంక్రీజ్ అయిందంటే ఆల్ఫా డిక్రీజ్ అవ్వాలి కదా, ఇన్వర్స్. అదే డి ఆప్షన్ ఏమి ఇచ్చినాడంటే వెన్ P ఇంక్రీజెస్ ఆల్ఫా డిక్రీజెస్. ఇది కరెక్ట్. ఆల్ఫా ఈజ్ ఈక్వల్ టు అండర్ రూట్ కేపీ బై పీ. P increase అయిందంటే alpha decrease అవుతుంది. This is your JEE mains April to 2025 question. Same data question they have asked. Clear? అర్థమైందా? See, this type of the questions only they are asking. నెక్స్ట్ సేమ్ ఇదే కాన్సెప్ట్ నుంచి ఇంకొక క్వశ్చన్ ఇస్తా చెయ్యి. ఇప్పుడు వాట్ ఈజ్ సేయింగ్, ఒక ఏబి టు డిసోసియేట్ టు గివ్ ఏబి. ఇప్పుడు నువ్వు ఎగ్జామ్లో సాల్వ్ చేస్తా అన్నావు కదా, సేమ్ అదే ఇక్కడ సాల్వ్ చేసి నాకు చెప్పు. ఇప్పుడు ఈ రియాక్షన్ ఇచ్చినాడు, ఓకేనా? వాట్ ఈజ్ సేయింగ్ ఆల్ఫా ఈజ్ వెరీ 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 లెస్ దాన్ 1. అంటే నువ్వు ఆల్ఫాని నెగ్లెక్ట్ చేసుకో, అంటే ఎక్స్ తీసుకుంటున్నాం కదా మనం, ఎక్సే ఆల్ఫా అనుకో. ఆల్ఫాని నెగ్లెక్ట్ చేయొచ్చు, యూ కెన్ నెగ్లెక్ట్ ద ఆల్ఫా వాల్యూ. ఓకే, 1 మైనస్ ఆల్ఫా యూ కెన్ నెగ్లెక్ట్ క్వశ్చన్లో. నౌ ద కరెక్ట్ ఎక్స్ప్రెషన్ ఫర్ ఎక్స్ in terms of kp and p, in terms of kp and p చెప్పు ఆన్సర్. ఆప్షన్ ఏ ఇచ్చినాడు రూట్ 3 2kp బై p. బి ఇచ్చినాడు రూట్ 4 2kp బై p. సి ఇచ్చినాడు రూట్ 3 2kp స్క్వేర్ బై p. డి ఇచ్చినాడు రూట్ kp. ట్రై చేయి. అవసరం లేదు, x/2 ఎందుకు? ఏది x/2 అంటున్నావు? ఇది 1 కదా, 1కి 1 అంటే a మైనస్ ఎక్స్ అంటే ఇక్కడ ఎక్స్, ఇక్కడ ఏంది x/2, ఇక్కడ x/2 తీసుకోవాలి. షుడ్ ఐ టేక్ x/2? బీకి x/2 తీసుకోవాలి, బీకి x/2. ఓకే చెయ్యి. ఐ విల్ వెయిట్. Same question they have asked in this year only, January 29, 2025. January 29, 2025 they have asked. Now what is the answer? Okay, sir. Now listen. Here AB2 gas gives rise to AB gas plus half B2 gas kada. Okay, initially if you take this as a 1 mole, ఇది 0 0 1 కి x dissociate అయింది, x by 2 ఫామ్ అయింది. ఓకేనా? ఈజ్ ఆస్కింగ్ ఇన్ ద ఫార్మ్ ఆఫ్ ద విచ్ వన్ కేపీ కదా. మరి కేపీకి ఏముండాలి? పీ టోటల్ ఉండాలి. పీ టోటల్ ఎట్లా? 1 మైనస్ ఎక్స్ ప్లస్ ఎక్స్ బై 2. మరి పీ టోటల్ ఎంత అయిపోతుంది? 1 ప్లస్ ఎక్స్ బై 2 అయిపోతుంది. 1 ప్లస్ ఎక్స్ బై 2 కదా. ఎక్కడేమంటున్నాడు? ఎక్స్ ఈస్ వెరీ వెరీ నెగ్లిజిబుల్. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆఫ్ ఎక్స్ ఈస్ వెరీ వెరీ లెస్ దాన్ 1 అంటే దిస్ ఓవరాల్ వాల్యూ విల్ బికమ్ 1 అంటే మనం దీన్ని కన్సిడర్ చేయని అవసరం లేదు. దెర్ ఈస్ నో నీడ్ టు కన్సిడర్ దిస్ వన్. పీ టోటల్ ని కన్సిడర్ చేయని అవసరం లేదు. సో వెన్ దెర్ ఈస్ నో నీడ్ టు కన్సిడర్ ద పీ టోటల్, ద కేపీ విల్ బి ఎక్స్ప్రెస్డ్ యాజ్ కేపీ విల్ బి ఈక్వల్ టు ఎక్స్ ఇంటూ పీటీ, ఎక్స్ ఇంటూ పీటీ. ఎందుకంటే 1 by x by 2 విల్ బికమ్ 1 ఇంటూ x by 2 ఇంటూ పీటీ హోల్ పవర్ 1 by 2 బై నెక్స్ట్ 1 మైనస్ ఎక్స్ ఇంటూ పీటీ, 1 minus x into pt, because 1 by 1 plus x by 2 become 1, means this overall value will become 1, because for kp partial pressure number of moles by n total will be 1. Here number of moles by n total will be 1. Here number of moles by n total will be 1. So directly I was written. Okay, now here after that, after getting this one, to get in the terms of x, to get in the terms of the x, what I was doing, I was squaring on both sides, squaring on both sides. For this reaction, to get in the terms of x, I was doing the squaring on both sides. If I do the squaring on both sides, what it will happen? Now this will be the kp square. Now this will become x square pt square into x by 2 into pt, x by 2 into pt by pt. ఇది ఎంత అయిపోతుంది? 1 minus x whole square into pt square. Now you can see pt square will be get cancel. Clear? pt square will, oh sorry, ఇది 1 minus x unity కదా. Now this also we can take it as unity because x is very very less than 1. So this is also we can take it as 1. Now the pt square will be get cancel. Now the leftover will be, ఇక్కడ కూడా అంతే కదమ్మా, x is very very less than 1 అంటే 1 minus x will be tends to 1. So this will be tends to 1. Then pt square will be get cancel. Now kp square will be equal to ఎట్లా రాయొచ్చు? This one we can be written as x power 3 p by x power how to write this one? X power 3 pt by 2, x power 3 pt by 2. Then if you send it to the left hand side, x power 3 is equal to 2 kp square by pt. Now if you send the whole cube to the left hand side, x is equal to root 3 2 kp square by pt. So option which one will be correct? Option C will be correct. Okay na? Got it? See, based on this concept only, based on this type of the concepts only, how they are asking the question. Okay na? Now you got it, right? Can I give the another question? I mean same concept only. Can I give the another question? Will you try? Will you try? Same concept only. I will try. Okay, you try. Question they have given: a gas equilibrium with B gas plus C by 2 gas. Okay na? Correct relationship between Kp, alpha and P. What is asking? What is the correct relationship between Kp, alpha and P? Option A is given. Kp is equal to alpha 1 by 2 into P 1 by 2 by 2 plus alpha whole power 1 by 2. B they have given Kp is equal to alpha 3 by 2 into P 1 by 2. No, it is not negligible. Negligible kaadu. Now alpha you should not negligible. It is not negligible. Now alpha you have to consider in this reaction. 2 plus alpha 1 by 2 1 minus alpha. C Kp will be equal to alpha 1 by 2 into P 3 by 2 by 2 plus alpha 3 by 2. D Kp will be equal to alpha 1 by 2 into P 1 by 2 by 2 plus alpha 3 by 2. Now same is the answer. B. Answer is B. Right. Good. Okay, good. Answer is B. Right. Answer is B. Good. Same this type of the question data only. Another one I will give. I mean now same thing. Question he has given X2Y gas equilibrium with X2 gas plus half Y2 gas. X2 gas plus half Y2 gas. Now the equation representing correct relation between degree of dissociation X. Degree of dissociation they have given in the terms of X of X2Y gas with Kp. With Kp is here also here alpha is very negligible. Alpha is very less than 1. Now here the degree of dissociation alpha is very less than 1. Now see me. Option A, X is equal to √3 2 Kp by P. B, X is equal to √3 2 Kp whole square by P. అంతే కరెక్టే 12th one బియా అంతే వస్తుంది డిగ్రీ ఆఫ్ డిసోసియేషన్ డెల్టా ఇంజిన్ నెగ్లిజిబుల్ చేస్తే 12th one బి అంతే కరెక్టే సేమ్ డెల్టా ఇంజిన్ నెగ్లిజిబుల్ చేస్తే బి వస్తుంది డెల్టా ఎన్జీ నెగ్లిజిబుల్ డెల్టా ఆల్ఫా నెగ్లిజిబుల్ చేయకుంటే లెంతీ కాన్సెప్ట్ వస్తుంది. నెక్స్ట్ ఓకే, నెక్స్ట్ ఓకేనా, క్లియర్ కదా? Now we'll move to the questions. We'll move to the concept now. Now, based on this concept, we got the answer. Next, very important questions they may ask. ఈ కాన్సెప్ట్ అయిపోయిన తర్వాత ఇంకో కాన్సెప్ట్ నుంచి ఎక్కువ క్వశ్చన్లు అడిగేది డిగ్రీ ఆఫ్ డిసోసియేషన్. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా. డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా. Now, degree of dissociation alpha, if you want to express the degree of dissociation alpha, for this alpha, reactant should be 1 mole. Okay na? Reactant should be 1 mole. That 1 mole of reactant, it may give n moles of products. Let's suppose 1 mole of A giving n moles of B. Okay na? At initial time t is equal to 0. Now 1 mole, right? Here it will be the 0. At a time t is equal to equilibrium, from 1 mole alpha moles has been dissociated. N alpha moles has been formed. Right? Now this reaction is happening in the closed container. ikkadino clear ga ee formula etla vachindi annadi chaala important. దీని మీద క్వశ్చన్స్ కూడా చాలా ఇంపార్టెంట్. నౌ ఇనిషియల్ గా నెంబర్ ఆఫ్ మోల్స్, ఇప్పుడు దిస్ రియాక్షన్ విల్ బి హ్యాపెన్ ఇన్ ద క్లోజ్డ్ కంటైనర్ కదా. వెన్ దిస్ రియాక్షన్ ఈజ్ హ్యాపెనింగ్ ఇన్ ద క్లోజ్డ్ కంటైనర్, బిఫోర్ అటైనింగ్ ద ఈక్విలిబ్రియం, ఇనిషియల్ గా నెంబర్ ఆఫ్ మోల్స్, ది రియాక్షన్ యొక్క నెంబర్ ఆఫ్ మోల్స్ ఇనిషియల్ గా స్టార్టింగ్ లో క్యాలిక్యులేట్ చేస్తే నెంబర్ ఆఫ్ మోల్స్ ఫార్ములా అయింది వెయిట్ బై మాలిక్యులర్ వెయిట్ థియరిటికల్. ఓకేనా, మాలిక్యులర్ వెయిట్ థియరిటికల్ ఎట్ ఈక్విలిబ్రియం. ఇప్పుడు ఇక్కడ ఈక్విలిబ్రియం దగ్గర ఇనిషియల్ గా స్టార్టింగ్ లో ఏ మాత్రమే ఉండే, ఏ వెయిట్ ఎంత 1. ఓకేనా, దాని మాలిక్యులర్ వెయిట్ సంథింగ్ థియరిటికల్ గా క్వశ్చన్ లో ఇస్తాడు. ఇది ఈక్వేషన్ నెంబర్ 1. ఇప్పుడు రియాక్షన్ ఈక్విలిబ్రియంకి వచ్చినప్పుడు ఈ కంటైనర్లో స్టార్టింగ్ లో 1 మోల్ ఆఫ్ ఏ ఉండే. ఈ కంటైనర్ యొక్క టోటల్ నెంబర్ ఆఫ్ మోల్స్ క్యాలిక్యులేట్ చేస్తే నాకు వెయిట్ బై మాలిక్యులర్ వెయిట్ థియరిటికల్ ఇట్లా క్యాలిక్యులేట్ చేయొచ్చు. ఇప్పుడు రియాక్షన్ ఈక్విలిబ్రియంలోకి వచ్చి ఒక ప్రోడక్ట్ ఇచ్చింది. అంటే ఇప్పుడు ఇక్కడ రియాక్షన్లో ఏ ఉంది, ఈ మొత్తం కంటైనర్లో ఏ ఉంది ప్లస్ బి కూడా ఉంది. అంటే మిక్చర్ కదా, ఇది మిక్చర్ కదా. అంటే ఇక్కడ నేను ఎన్ టోటల్ క్యాలిక్యులేట్ చేయొచ్చు కదా. ఎన్ టోటల్ ఈజ్ ఈక్వల్ టు వెయిట్ బై మాలిక్యులర్ వెయిట్ ఆఫ్ మిక్చర్. ఎందుకు, బిఫోర్ ఇనిషియల్గా ఏ మాత్రమే ఉంది, దాని మాలిక్యులర్ వెయిట్ ఏ తీసుకున్నాను, ఒక మాలిక్యులర్ వెయిట్ ఆఫ్ థియరిటికల్. కానీ ఈక్విలిబ్రియం రియాక్షన్కి వచ్చిన తర్వాత ఏ వచ్చింది, బి వచ్చింది. మరి ఇప్పుడు నాకు టోటల్ నెంబర్ ఆఫ్ మోల్స్ ఆఫ్ దట్ రియాక్షన్ కావాలి అని అంటే మాలిక్యులర్ వెయిట్ ఆఫ్ ద మిక్చరే కదా నేను చెప్పొచ్చు. నౌ కానీ ఇక్కడ నాకు ఒకటి, ఫర్ ఎ క్లోజ్డ్ కంటైనర్, ఇఫ్ ద రియాక్షన్ ఈస్ అండర్గోయింగ్ ఇన్ దట్ క్లోజ్డ్ కంటైనర్, వెయిట్ విల్ బి చేంజ్ ఆర్ ఇట్ విల్ నాట్ చేంజ్. ఇది ఒక్కటి చెప్పు, ఇది చెప్తే నీకు ఈ కాన్సెప్ట్ అర్థమైందా లేదా తెలిసిపోతుంది. ఇన్ ఏ క్లోజ్డ్ కంటైనర్, when the reaction is attained the equilibrium, whatever may be the weight we have taken initially, it will be same or it will be different. ఇప్పుడు ఈ రియాక్షన్ కి నేను 1 మోల్ ఆఫ్ ఏ తీసుకున్నా. 1 మోల్ ఆఫ్ ఏ తీసుకొని రియాక్షన్ చేసి ఈక్విలిబ్రియంకి అటెండ్ అయింది. ఇప్పుడు ఈక్విలిబ్రియంకి అటెండ్ అయినప్పుడు ఇక్కడ బి ఇనిషియల్ గా బి లేదు, ఇప్పుడు బి ఫామ్ అయింది. మరి ఇప్పుడు బి ఫామ్ అయినప్పుడు ఈ టోటల్ కంటైనర్ యొక్క వెయిట్ చేంజ్ అవుతుందా, సేమ్ ఉంటుందా? ఇనిషియల్గా ఎంత వెయిట్ అయితే కంటైనర్ ఉందో ఈక్విలిబ్రియంకి వచ్చిన తర్వాత కూడా ఆ కంటైనర్ యొక్క వెయిట్ సేమ్ ఉంటుందా, డిఫరెంట్ ఉంటుందా? సేమి తెలిసే చెప్పు, తెలియకపోతే క్వశ్చన్ మార్క్ ఇవి, నేను ఎక్స్ప్లెయిన్ చేస్తా. ఐ విల్ ఎక్స్ప్లెయిన్. ఎందుకంటే ఈ కాన్సెప్ట్ ఇట్ ఈస్ డిపెండింగ్ అపాన్ దిస్ వన్ ఓన్లీ. నౌ ద ఇనిషియల్లీ ఐ హ్యావ్ టేకెన్ ద A as 1 mole. Then when it has reached to the equilibrium, when it has reached to the equilibrium, then it has become n total. Then you have to consider that whatever may be the weight you have taken initially, after attaining the equilibrium also, this weight of that container will be fixed. Weight of that container will be fixed. There is no any change in the weight of the container. Clear? Then if you divide it 1 by 2, if you divide 2 by 1, then 2 is the n total. N total by n will be equal to molecular weight of theoretical by molecular weight of mixture. This we will get. Now n total, what we are having? 1 minus alpha plus n alpha, because here the 1 minus alpha plus n alpha will be the n total. Initially the number of moles of the initial is 1. Then 1 minus alpha plus n alpha will be equal to molecular weight theoretical by molecular weight mixture. Clear? Now this one we can say it as this is a formula. This is a degree of dissociation formula. Now degree of dissociation formula, we know the vapor density formula. Vapor density is equal to molecular weight by 2. Molecular weight is equal to 2 into vapor density. Then we can say, if we modified this formula, we can modify in this manner: 1 plus n minus 1 alpha is equal to capital D by small d. This capital D indicates that vapor density theoretical. This is vapor density theoretical. Now this is vapor density mixture. Based on this formula, now we have to solve these questions. Okay, fine. Now are you leaving the class? Class intava? Okay, sorry. Right. Class intava eltunava? Now this is a degree of dissociation formula. Now the degree of dissociation formula, we got it as 1 into n minus 1 alpha is equal to vapor density theoretical by vapor density mixture. Vapor density theoretical by vapor density mixture. This is the answer. Now here what is the n here? N is the number of moles of gaseous products. When 1 mole of gas reactant, 1 mole of gaseous reactant as not dissociated. Okay, as not dissociated. Okay, no problem. Now this is a degree of dissociation alpha formula. Okay na? Degree of dissociation alpha formula 1 plus n minus 1 alpha into vapor density theoretical by vapor density mixture. Right? Now you got it right? Now based on this formula, now we'll do one question. Based on this formula, we'll do one question. The question he has given: vapor density of N2O4 at a certain temperature is 30. Okay na? Calculate the percentage dissociation of N2O4 at this temperature. What is the N2O4? Now N2O4 is dissociating into 2NO2. Okay na? N2O4 is dissociating into 2NO4. Now is asking the percentage dissociation. Find the alpha, then you will get the percentage dissociation. should this is the formula. 1 plus n minus 1 alpha is equal to vapor density theoretical by vapor density mixture. Vapor density theoretical by vapor density mixture. 1 plus n minus alpha is equal to vapor density theoretical by vapor density mixture. Okay na? Already vapor density of mixture they have given already 30. Already vapor density of the mixture they have given it as a 30. Vapor density of the mixture they have given. Vapor density theoretical you can calculate. N2O4 molecular weight will be 92. N2O4 molecular weight is 92 by 2. If you do, you will get the 46. That you will get it as a 46. That we call it as a vapor density theoretical. Then is asking the alpha, right? 1 plus here 1 minus 2. N is nothing but gaseous products minus gaseous reactants. 2 minus 1. That it will be equal to n will be number of gaseous products. Number of gaseous products are 2. 2 minus 1 is equal to 46 by 30. 30. This is alpha 0.53. Approx 50%. Yes, approx 50% you will get. Then you will get it as then alpha is equal to 46 by 30 minus 1. You will get it as 16. Approx you will get it as 50. 46 minus 30 by 30. If you do, you will get the alpha. That into 100 if you do, you will get the answer. Okay. Right. Now, then after that, after the degree of dissociation concept, the next very important concept that we are having, it is a Lee-Chatelier principle. Ikkada Lee-Chatelier principle. Now, listen carefully. Based on the concept, you have to answer. First, I will explain the concept on the basis of each and every. When we change the concentration pressure, external pressure concentration changes, how the Lee-Chatelier principle is changing. Okay. Yes, 53.3. Good, Vaishnavi, good. Now, right. What is the meaning of the Lee-Chatelier principle? Lee-Chatelier principle, it is applicable for both physical and chemical equilibrium. Okay, it is applicable for both chemical and equilibrium. Right? What is the meaning of the Lee-Chatelier principle? Lee-Chatelier principle, when the equilibrium, let's suppose A gives rise to B. For this A gives rise to B, this is equilibrium. If this equilibrium, if I was disturbed by the concentration, if I was disturbed by the pressure, if I was disturbed this equilibrium by temperature, then where the equilibrium should move to balance it, that we are going to study on the basis of Lee-Chatelier principle. Okay. Now the Lee-Chatelier principle, first we are going to study on the basis of effect of concentration. Right. First one, that's what I am saying. Okay. First we are going to see Lee-Chatelier principle. If you disturb the equilibrium by changing the concentration, what happened to the equilibrium? Reaction will move forward direction or backward direction, that we will see. Let's suppose PCl5 gas. Okay na? PCl5 gas is converting into PCl3 gas plus Cl2 gas. Okay. Now, at equilibrium, QC will be equal to Kc, right? QC will be equal to Kc. Then this reaction, no, reactants concentration is let's suppose 1, 0, 0. At equilibrium 1 minus 0.5, 0.5, not 0.5, 0.5 has been formed. Now here I will write one statement based on this one. Now you have to say me, if product concentration, if I was increased, reaction equilibrium కి వచ్చిన తర్వాత ఈ ఈక్విలిబ్రియం రియాక్షన్ ని నేను చేంజ్ చేద్దాం అనుకుంటున్నా. How I am going to change for this equilibrium reaction? I want to disturb this equilibrium reaction by increasing the concentration of the products. To attain the equilibrium, reaction should move forward direction or backward direction. Now you see. Now when the effect of concentration shift backward direction, good. How? Now at the equilibrium we can say it as Kc, but now I am increasing the concentration of reactants, then I was disturbed the equilibrium, then I cannot say it as a Kc, then I can say it as a Qc. Qc is equal to concentration of products by concentration of reactants. Now if I am increasing the concentration of products, then Qc value will be increased. If the Qc value is greater than Kc, to attain the equilibrium, reaction moves backward direction. Good. Okay na? Now if reactants concentration, if I was decreasing, if reactant concentration if I was decreasing, now to attain the equilibrium, reaction should move which direction, backward or forward? Reaction concentration I was decreasing, then to attain the equilibrium, reaction should same. Put reactant తగ్గించిన అంటే QC will be increased. If the QC is increasing, reaction to attain, now it should move the backward only. Okay na? Right. If suppose reactants concentration if I was increasing, now QC will be decreased. QC will be decreased means reaction to attain, it should move to the forward direction. Okay na? Right. Now this is on the basis of concentration. Now second one, effect of pressure. Now if you change the pressure of that equilibrium reaction, how the equilibrium reaction will move, at which side will be equilibrium reaction will move? Right, see, on increasing pressure, reaction will shift in that direction, in which total number of gaseous moles decreasing. Okay, reacts in that direction in which total number of gaseous moles decreasing. Reaction will shift in that direction where the total number of gaseous moles decreasing. Clear? Now you say me, if the pressure increases, equilibrium will shift in that direction. If the pressure increases, equilibrium shift in that direction where lower moles of gaseous are there. If we decrease the pressure, equilibrium shift where more gaseous moles are there. Okay na? These two key points you have to remember. If delta Ng is equal to 0, no effect of pressure. ఎందుకు? రెండు సైడ్ల నెంబర్ ఆఫ్ మోల్స్ సేమ్ కాబట్టి ప్రెషర్ ఎక్కడ చేంజ్ చేసినా ఈక్విలిబ్రియం సేమ్ ఉంటుంది. if delta Ng is equal to positive, if pressure increases, equilibrium will shift to which direction? Now same, delta Ng is positive, if pressure increases, equilibrium will shift in which direction? If delta Ng positive ante PCl5 gas gives rise to PCl3 gas plus Cl2 gas. ఇప్పుడు ఈ రియాక్షన్కి బ్యాక్వర్డే నేనేం చెప్పినా, if the pressure increases, equilibrium shift to where the number of moles of gaseous lower moles of gaseous side పోతుంది, lower number of moles. See, if the delta N is positive for this reaction, if I was increasing the pressure, now the equilibrium will shift towards the where the number of moles of gaseous products are less, so equilibrium will shift backward. Okay na? If delta Ng is negative, అంటే N2O4 gives rise to 2NO2, ఇది delta Ng negative. Delta Ng negative అంటే for this reaction, if I increase the pressure, now reaction will move forward direction. Okay, next, this is a very important that you have to remember, effect of inert gas. Many of the students, they will get confused here only. Effect of inert gas దగ్గర, effect of inert gas at constant volume, delta Ng is greater than 0. Okay na? Delta Ng greater than 0. At constant volume, if you add the inert gas, what happened to the equilibrium? So very key point, no effect of equilibrium when inert gas is added. Constant volume దగ్గర inert gas యాడ్ చేస్తే no effect of equilibrium when inert gas is added. ఎందుకు అనంటే, let's suppose PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Okay, now you can see here Kc will be equal to x square by a minus x into v, ఇక్కడ వాల్యూమ్ కాన్స్టెంట్ కదా, మనం కాన్స్టెంట్ వాల్యూమ్ తీసుకున్నాం కదా. కేసీకి కాన్స్టెంట్ వాల్యూమ్ అంటే ఈ వాల్యూమ్ టర్మ్ క్యాన్సిల్ అయిపోతుంది, అంటే దిస్ వాల్యూమ్ టర్మ్ విల్ బికమ్ 1, అంటే ఇప్పుడు ఈ రియాక్షన్కి దిస్ ఈజ్ ఈక్విలిబ్రియం, ఇట్ హాస్ బీన్ అటైన్డ్. దీనికి ఇక్కడ ఇన్నట్ గ్యాస్ యాడ్ చేసిన, ఎక్కడ కాన్స్టెంట్ వాల్యూమ్ దగ్గర ఇన్నట్ గ్యాస్ యాడ్ చేస్తే నీకు వాల్యూమ్ టర్మే లేదు కేసీలో. కేసీలో లేనప్పుడు నీకు కేసీ ఎందుకు చేంజ్ అవుతుంది? కేసీ చేంజ్ కానప్పుడు నీకు ఈక్విలిబ్రియం చేంజ్ అవ్వదు, అంతే కదా. ఇప్పుడు నీకు ఇక్కడ కేసీలో వి ఉంది ఒకటి, కానీ వి మన కాన్స్టెంట్ వాల్యూమ్ కాబట్టి అది యూనిటీ 1 అయిపోయినప్పుడు నీకు ఇక్కడ ఈక్విలిబ్రియం రియాక్షన్ దగ్గర నువ్వు ఇన్నట్ గ్యాస్ యాడ్ చేసినా కూడా నీకు కేసీ డిస్టర్బ్ అవుతలేదు. అంటే ఈక్విలిబ్రియం డిస్టర్బ్ అవుతలేదు అని అర్థం. ఈ ఈక్విలిబ్రియం డిస్టర్బ్ కాకపోతే నీకు ఈక్విలిబ్రియం ఎందుకు చేంజ్ అవుతుంది? నువ్వు గ్యాస్ యాడ్ చేసినా కూడా. ఐ హోప్ ఇట్ ఈస్ క్లియర్. అందుకే నో ఎఫెక్ట్ ఆఫ్ ఈక్విలిబ్రియం వెన్ ఇన్నట్ గ్యాస్ ఈస్ యాడెడ్ ఎట్ కాన్స్టెంట్ వాల్యూమ్ దగ్గర ఇన్నట్ గ్యాస్ యాడ్ చేస్తే మనకి ఏం ఎఫెక్ట్ ఉండదు. ఐ హోప్ ఇట్ ఈస్ క్లియర్. డన్. ఇప్పుడు ఇది వెరీ ఇంపార్టెంట్. ఓకేనా? నౌ ఎట్ కాన్స్టెంట్ ప్రెషర్ దగ్గర, if we add the inert gas to the equilibrium reaction, ఇప్పుడు ఇది ఈక్విలిబ్రియం రియాక్షన్ కి ఒక ఇన్నట్ గ్యాస్ యాడ్ చేసిన He యాడ్ చేస్తే ఏమైపోయిందంటే ఈక్విలిబ్రియం రియాక్షన్ యొక్క వాల్యూమ్ పెరిగిపోయింది. దిస్ ఈక్విలిబ్రియం రియాక్షన్ వాల్యూమ్ హ్యాస్ బీన్ ఇంక్రీస్డ్. నౌ ఇఫ్ దిస్ హ్యాస్ బీన్ ఇంక్రీస్డ్, నౌ వాట్ హ్యాపెన్ టు ద ఈక్విలిబ్రియం? మరి ఇప్పుడు ఈక్విలిబ్రియం ఎటు షిఫ్ట్ అవ్వాలి? ఫార్వర్డ్ డైరెక్షనా, బ్యాక్వర్డ్ డైరెక్షనా? దే విల్ ఆస్క్. ఓకే, at constant pressure, when you add the inert gas, equilibrium will shift in which direction? So at constant pressure, same PCl5 gas gives rise to PCl3 gas plus Cl2 gas. Done. Now Kc will be equal to x square by A minus X into V. Then when I was added the inert gas at the constant pressure, now the volume will be changed. How much volume will be changed? That it will become, after the equilibrium got disturbed, means that it will become QC. QC will be X square by A minus X V plus change in volume, that it will be delta V. See, at a constant pressure, when I have added the helium or inert gas to the equilibrium reaction, now overall volume is increasing. Overall volume is increasing means QC is decreasing. If QC is decreasing, then what it will happen? See, at a constant pressure, if I am adding inert gas, now overall my volume is increasing, means QC is decreasing. Means if the QC is less than Kc, then equilibrium to attain, it should move to the forward direction. It should move forward direction. I hope it is clear. ఎప్పుడు డెల్టా ఎన్జీ గ్రేటర్ దాన్ జీరోకి, ఒకవేళ డెల్టా ఎన్జీ లెస్ దాన్ జీరో ఉందనుకో, రియాక్షన్ డెల్టా ఎన్జీ లెస్ దాన్ జీరో ఉందనుకో, అప్పుడు ఏమవుతుంది? బ్యాక్వర్డ్ డైరెక్షన్లో వెళ్తుంది. బ్యాక్వర్డ్ డైరెక్షన్. ఓకేనా? క్లియరా? ఐ హోప్ ఇట్ ఈస్ క్లియర్. నేను ఒక క్వశ్చన్ ఇస్తా, చెప్పు దీని మీద. నౌ బేస్డ్ ఆన్ దిస్ వన్ ఐ విల్ గివ్ యూ వన్ క్వశ్చన్. లీ చాట్లియర్ ప్రిన్సిపల్. నౌ సే మీ ద ఆన్సర్. Now the question he has given, same 2020-25 question only. Yes Nana, Pranit, say me. Chuppo. Oh, sorry. Okay. Okay. QC is less than case. Greater than Rasina. Okay, done. No. PCl3 gas plus Cl2 gas. Okay. Now this reaction they have given. He has given upon addition of xenon at a constant temperature pressure. Constant temperature pressure. The concentration will be the concentration of. He has given this question. Option A, PCl5 will increase. B, Cl2 will decrease. C, PCl5, PCl3, Cl2 remains constant. D, PCl3 will be increased. Say me the answer. For this reaction, upon addition of xenon at a constant pressure, now what it will happen? PCl5 will be increased. Cl2 will decrease. PCl5, PCl3, Cl2 remains constant. PCl3 will be increased. Now say me the answer. Simple, same concept. Same concept. ఏనా? How come? అయ్యా మరి సేమ్ కాన్సెప్ట్ నానా. ఫార్వర్డ్ మరి now you can see at a constant pressure delta Ng greater than 0 means QC will be less. QC will be less means Kc will be high. Kc will be high means forward reaction. Forward reaction means PCl5 moles will be decreased, but here he has given increase, wrong. Cl2 will be decreased. No, Cl2 moles will be increased, but it is wrong. PCl5 will be have remained same concentration, wrong. PCl3 concentration increases at D. Ante, simple. Clear? Now by this all the concepts has been completed by the chemical equilibrium. Remaining questions part will do one by one in the like daily at 9:30 or 10 to 11 or 9:30 to 11 or 10:30, 1 hour daily. 1 hour we'll do the question sections chapter by chapter. Okay, one day atomic structure, one day classification of periodic table, one day chemical bonding, one day cumulative. Okay, now I was ending the live by year. Still anyone having any doubts? ఎవరికన్నా ఏమైనా డౌట్స్ ఉన్నాయా? Anyone having any doubts, they can ask. Remaining, they can leave. Okay, sir, done. Bye, Nana. Bye. Good night, everyone. Good night. Good night. Okay, fine, fine. Good night.